If the panelists for the first panel could please come up and take their seat, we're going to get started now, please. Good morning, everyone. I'd like to thank you all for coming today. My name is Cecilia Solhoff. I'm in the Wireless Telecommunications Bureau here at the FCC. We are broadcasting this forum live on the web. There's going to be several PowerPoint presentations given by some of the panelists today, and those will be available after the forum on the website at www.fcc.gov/events/forum-indoor-deployments-small-cell-sites. So just take the title of the forum, put a bunch of dashes in between, and you'll find it. There's also a couple of handouts at the back table here where you came in, the PN with the agenda for the day and the bios of the panelists that are going to be speaking. If you think of any questions throughout the day during the panels, Marasha, who's sitting at the back table there, has some note cards and pens, so just kind of raise your hand, jot down your question, and then either give it right back to her or try to capture her or my attention, and we'll collect the note cards from you and give them to the moderators to ask the panelists. There will also be a break at lunch. We're scheduled for just a 15-minute break because we are having a lunchtime speaker. So we encourage you to go to the courtyard level off of the elevators, grab some lunch, and then bring it back here to the commission meeting room so you can eat while you're watching the lunchtime speaker. And now I'd like to introduce John Leibovitz, who is a Deputy Chief here in the Wireless Telecommunications Bureau.
So welcome to today's event on indoor small cell deployments. We're here to discuss an exciting set of developments in wireless technology. As some of you may know, the latest survey from J.D. Power, which measures wireless quality, estimated that over 50% of wireless calls happen indoors. So this suggests that small cells will have an important role to play as we address our country's spectrum challenges going forward. We have a really great lineup of panels and speakers today. As Cecilia mentioned, the bios are on a handout, which you can get at the door. I just want to quickly go over the agenda to kind of give a sense of the flow of things. So Tom Wheeler, who's the chairman of the TAC, will provide some opening remarks. We're going to have three panels. The first panel on technologies. Our goal is to provide just kind of an overview of the different approaches to small cells that are out there in the industry these days. The second is a panel on business opportunities, but also challenges where there may be some inhibitors to small cell uptake and what might be some opportunities that could arise from solving those challenges. And then third, a panel which will consist of members of the Technological Advisory Council, the TAC, which was the genesis of today's forum, discussing some of the policy approaches that we might take to address some of those challenges raised in the second panel. As Cecilia mentioned, there'll be a lunch speaker. We've got Ed Cantwell from West Wireless Institute. He's going to talk about applications of small cells in healthcare environment. Should be very interesting. And we also have a display set up in the other corner over there with several small cell devices from different panelist companies. I encourage you to go over there, but not to step on the small cells. So today, to start the festivities, I want to introduce Tom Wheeler. Probably most of you have encountered Tom in some form or fashion, but as you know, he's got a lot of hats. He's a technology investor, a Lincoln scholar, a telecom guru, and maybe he would say his proudest achievement, an Ohio State alum. So today he's here in his capacity of chair of the Technological Advisory Council, which, as I mentioned before, was the group that recommended that the FCC hold this forum and raise several of the issues that we'll discuss today. So thanks, Tom.
Great. Thank you, John. On behalf of the TAC, welcome everybody to, as Cecilia explained to you, the meeting about small cells with the largest and longest URL. The Technological Advisory Council, as John commented, is the sponsor of today's session. This is an outgrowth of the work of the TAC, and I would be highly remiss if I didn't recognize a lot of the members of the TAC who have done great work on this. Dennis Robertson has chaired our sharing working group, Dale Hatfield, Brian Daly, and the irrepressible Jesse Russell, who I must say that if it weren't for Jesse and his persistence on this topic, we probably wouldn't be sitting here today. So thank you to the members of the TAC for everything that you have done to pull this together. And of course, we all recognize who does the real work, and that's the great staff that's here at the FCC, Julie Knapp, Charles Mathias, Leon Jackler, Cecilia, who you have already met, and John Leibovitz, who you have also already met. When Chairman Janikowski convened the TAC, he said to us that we should focus on a couple of specific goals, and today's activity fits inside that mandate. The first goal was that we should identify action that would spur investment, spur innovation, and create jobs. And the second is for us to make recommendations on how policy can keep pace with innovation. And so if you peel back the onion, those are really the two messages that we are going to be discussing here today. We can stipulate that wireless is the information delivery vehicle of the 21st century. CTIA just came out with a study that shows that wireless penetration in the United States is now greater than the population of the United States. Worldwide, there are more wireless devices in use than toothbrushes. There are more people connected to wireless networks than there are connected to the electric network. That reality, however, has set us on a collision course when it comes to the matter of spectrum. Moore's law makes it easier for devices to be more powerful and less expensive. Edge-based networks make it easier for apps developers to use that capability to flood the network with new activities. The result of those, as we all know, is the network, particularly the spectrum-based network, experiences huge pressures. And as Mark Twain once observed about real estate, they aren't making spectrum anymore. And so how do we deal with that? Next time you're at the grocery store, take a look at the print on the bottom of the paper bag that they give you at the checkout counter, and it normally in small print down there says something like 10 pounds, or it indicates how much the bag will hold. The challenge that Moore's law and the edge apps activities creates is that we're trying to put 12 pounds of apps into 10 pounds of spectrum. And we know what happens at the grocery checkout when we do that with a paper bag, and we've got to figure out ways to deal with that with our spectrum bag. And there are only two ways. One is we have to do something to free up more spectrum to make it available. And the FCC and the Congress are at work on that right now through voluntary incentive auctions as the first step. NTIA is at work on identifying other spectrum availabilities. Work is active around the world trying to work on harmonization. That's one component. The second component is we can be more efficient in how we use the spectrum, and that's the topic that we're discussing today. So the goals of today are, how do we get a clear definition of the opportunity and the scope represented by small cell reuse of finite spectrum? And how do we identify the inhibitors as well as the accelerators that stand in the way or could assist in that realization? Now, as the guy standing between you and substance, before I turn it over to these folks, one final observation on the goals of this meeting. We are meeting at a regulatory agency. We are going to be discussing policy recommendations. But it would be a mistake if we define the work product as FCC regulations or FCC rulemakings. The agility of the private sector, the economic incentive of the private sector must be the major component that attacks and then solves this problem. It's not to rule out regulation, but it is, how do we come out of this meeting today saying, here are the kinds of things that the private sector can do to take advantage of the opportunity, and what are the things that the FCC can do to expedite that. And the term expedite and notice of proposed rulemaking seldom occur in the same sentence. So that's the challenge that we have today. We've got a great group to start off with. Thank you to all the panelists who are here and who have dedicated their day to discussing this and sharing their insights with us. But one more step before we proceed to this opening panel. Chairman Janikowski wanted to be with us today, unfortunately was unable to, but is able to join us via, I guess you don't say via videotape anymore, is able to join us via video. So let's look at that for a second. Okay, did anybody have any questions about the chairman's remarks? There we go.
Good morning, and thank you, Tom Wheeler. Tom, you've been an incredible leader of the FCC's Technology Advisory Council, whose ideas were the genesis of today's event. Special thanks to the excellent lineup of panelists who will share their insights and experiences. As all of you know, the world is going mobile. In America, active mobile phones now outnumber people, with 328 million subscriptions. And the majority of new phones being activated are smartphones, which place 24 times as much demand on spectrum as the standard phones they replaced. Then you've got tablets, which create 120 times as much data traffic. This increase in demand has created a spectrum crunch, which poses a significant threat to one of the most promising sectors of our economy. That's why the FCC has made unleashing spectrum for mobile innovation one of our highest priorities. At the top of our mobile agenda, we've advocated voluntary incentive auctions, a market-based approach that would free up large blocks of beachfront spectrum for mobile broadband, while generating $25 billion in potential deficit reduction and many billions more in economic and social benefits. But we also need to do more. We need innovative approaches to use spectrum more efficiently. And that's what today's event is all about. Small cells can play an important role in expanding wireless coverage and capacity. They have tremendous potential for improving access to wireless broadband services inside our homes and businesses. We all know what it's like to have to stand near a window to make a call or check email. It's the modern equivalent of adjusting the rabbit ears on our TVs. And as integrated as mobile devices are in our professional and personal lives, it's just as unacceptable. For commercial real estate developers, an important industry we'll hear from today, not having the reliable mobile broadband that their tenants, particularly small businesses, rely on can make it very difficult to compete in the marketplace. Reliable in-building connectivity is also a public safety concern because people need to be able to reach first responders in an emergency. From pico cells to femto cells on the license bands, to Wi-Fi offload, to advances in antenna technologies and network architecture, there are a number of very promising approaches to efficiently addressing this issue. Today, you'll hear from a number of companies developing and deploying these technologies. In addition to the technology, you'll discuss business models and how economic interests of various stakeholders can be better aligned to provide incentives for building out the necessary infrastructure, improving broadband access, stimulating economic growth, and creating new jobs. I hope you'll discuss ways to facilitate solutions, including industry-led solutions to encourage new technologies, new spectrum access models, and new business opportunities. I want to thank the FCC's Spectrum Task Force for planning and hosting today's important event. And I want to thank all the members of the TAC for their ideas and support. Please keep them coming. Thanks for joining us, and enjoy the forum. Good morning, and
good morning. I'm Charles Mathias. I'm an Associate Bureau Chief in the Wireless Bureau, and I would like to continue the cascade of welcomes by welcoming you to our technology panel. We have a great cross-section of interests in the world of improving indoor coverage. We have CHIPS, we have DAS, we have licensed, we have unlicensed. We hope to have an exciting and dynamic panel. Look forward to having questions as we have time from the audience. And with that, I turn it over to my colleague to introduce the panel.
Okay. And I'm Tom Peters. I'm the Chief Engineer in the Wireless Bureau. Welcome to all of you. Thank you for coming. I have spent a large part of my career in the industry, wireless industry, trying to solve coverage and capacity problems, specifically indoors. And the time I've spent at the FCC has been involved with trying to solve issues related to this spectrum crunch that the chairman just spoke about. And those two subjects come together with small cells. So without further ado, let me briefly introduce the five panelists, and then we will jump into initial questions and presentations. So to my left, first of all, we have Rupert Baines. Rupert is the Vice President of Marketing at PicoChip. Also, I should note that for a more detailed description of each panelist, there's a handout with bios, as Cecilia mentioned. To Rupert's left is Stephen Kloppa. He is the Senior Director of Field Marketing at Ruckus Wireless. To his left, we have Keith Kaczmarek, the Vice President and General Manager of Global Wireless Solutions at PowerWave Technologies. And to Keith's left, we have Jim Seymour. Jim is the Senior Director of Wireless CTO Organization at Alcatel-Lucent. And finally, at the end, we have Jay Weitzen, is the Vice President of Technology at Airvana. Thank you for coming.
And to kick it off, I have a question for Jay. And for our audience, we've asked the panelists to prepare a few slides to go with the kickoff questions so that there will be, unfortunately, a little bit of juggling of the remote, but I hope you'll bear with us. Jay, could you please describe the types of small cells you've developed and have been deployed so far, and what major advances you foresee in the coming years as coverage and capacity needs increase?
Okay, so I push the button.
Yes, and the PowerPoint should come up.
A wireless device. Okay. All right, so every month we report to our customer Sprint how many 1,000 megabytes and how many million minutes of use our femto network provides. We're approximately somewhere around 175, 180,000 deployed femtocells. But when I'm not helping to run and understand how this large network works, I'm also an engineering professor at UMass. This is a problem we discussed last night in my wireless class. You don't have to turn in the homework. It basically says, try to provide at least 2 megabits per second, which is 3G kind of speeds, everywhere in the building without having to go to the window, without having to go outside. If you do, even using a rudimentary cell model, and I'm not going to do the math because you can clearly see it, you're coming with, especially out of the urban core, an unreasonable number of cells. With all regards to Wall Street, the laws of physics trump the laws of Wall Street, unfortunately. So the first real item for femtocells is to provide high-quality coverage everywhere. Over a period of about 2.5 years, I had my grad students and engineers from Sprint and a number of other operators take femtocells home and actually map out the coverage of the femtocell in their house and of the macro network. On the average, we were seeing approximately 3 to 5 times improvement in overall data throughput when you used a femtocell versus a macro cell. Now, when we talk about femtocells, we actually have to talk about what we mean by a femtocell, because there are a number of different sizes. They start from basically the residential femtocell, which is shown, and there are examples of both residential and enterprise on the table. Almost all the femtocells are hybrids of teeny tiny base stations, plus they are managed elements, managed usually by something like TR69 or a cable element. The residential femtocell generally can have anywhere from 4 to 10 users and maybe 20 milliwatts of power. The enterprise, usually now you're talking in the 30s. And then you go to what's called a femto-pico, which is a hybrid between a picocell and a femtocell. What's characteristic of femtocells versus straight picocells is femtocells usually are managed as ad hoc elements. That is, they have to figure out what channel they'll occupy and what their transmitter power ought to be. And they also tend to self-optimize. So with that in stake, we go from residential to enterprise to femtopicos, then to the next generation, which are small cells, which will be linked clusters of femtocells. That's sort of coming down the road. And I can see I'm out of time.
You are. Thank you.
All right, let's move to Keith Kaczmarek. Keith, as a vendor selling both DAS, that's distributed antenna systems, and as well as small cell solutions, can you provide a quick overview of the DAS concept and comparative uses and benefits versus that of small cells?
Great. Appreciate the opportunity to be here today. Excuse me. PowerWave represents distributed antenna systems. We have roughly 1,000 projects that we've deployed to date, more than 6,000 nodes. And I guess I would refer to DAS, distributed antenna systems, as sort of small cell before small cell was cool. I mean, really, it's been around for, 20 plus years. And one of our first systems that was deployed, the Moscone Center, really was about the idea that you needed to get better coverage. Coverage was a real fundamental issue. Right? The Moscone Center, it's down underground. You've got to find a way to drive coverage down underground. So that's where it started. It was a coverage game. And then what we've seen over time, of course, is that you really need to find a way to get capacity into these networks, into these systems. So first you start with coverage. You start with the fact that I deploy enough coverage throughout a geographic area that I get what I need to in terms of 2G, 3G, and actually in the original days, obviously even amps, level of coverage down there. And then I can start splitting. And in the same way I do in a macro world, I do it in a micro world. So I take, big cells, maybe they're a whole block long, and I make them half a block long. and then I make them even smaller than that over time. So what I do is I take, equipment that is basically base station gear, I convert it from RF to optical, I send it through the building, and then I regenerate it as RF. I mean, that's the basic concept around a DAS system. The evolution of this, of course, is that I need to take it one more step, and that is I need to put more and more capacity. So I may have started in the Moscone Center with one single base station, one cell site worth of capacity. Right now, there's one of the wireless operators, one of the national operators that has over 21 base stations worth of capacity in the Moscone Center. And it's re-radiated through different sectors, through different antennas throughout the Moscone Center. And what it allows us to do, not only can we carry any and all technologies, so you can change out that base station. You can go from amps to TDMA to CDMA or whatever you want. You can then eventually, bring in, whatever technology, whatever bands. Public safety is also able to be carried over those systems. So it's a great way to get going. And then as we showed on this slide there, then you eventually pop in picocells. Picocells gives you that next level of capacity. So I may have gone from 3 times a cell site worth of capacity to this example where I'm at 18 times the cell site capacity. This is kind of what it looks like. So there may be areas where I have to cover a pool or some fairly low capacity area. There's other areas where I need to bring another level of capacity, and then eventually the ultimate is I bring in picocell levels worth of capacity in the network. So we view this evolution from DAS to pico as a natural evolution in terms of the small cell world. I think the way to think about it just in terms of overall capacity, and apologize for this chart, it's kind of hard to see and hard to read. Again, it's taking big cells and making them smaller. And whether that's a picocell or whether that's a DAS sector, it all adds up to getting closer to the end user at the end of the day. The end user basically can now be closer, have a higher level of modulation, and really drive what they need to in terms of overall performance within the network. And appreciate the time.
Great. Thank you very much. It's impressive timekeeping on the.
Yes.
Steve, I've got a question for you. Should we consider Wi-Fi to be a viable small cell solution?
Well, the short answer is absolutely. Let me give you the 3-minute answer as soon as my slides come up here. Ruckus is in the business of Wi-Fi. We make a different class of Wi-Fi than most everyone else, and it's based on adaptive antenna technology that improves its performance very significantly. And I want to talk about the reasons, essentially 3 reasons why it's very important to think about Wi-Fi as a very viable small cell technology. First of all, it's a lot less expensive than cellular. The basic principle of riding an industry cost curve with the millions and millions of units that ship in Wi-Fi, and the fact that it is inherently designed for high capacity density. The self-organizing nature of the protocol and the way that the APs work together in an environment, even amongst themselves in a network and other networks, yields just a significantly lower cost structure than you get with cellular technology. And it's going to get even better. Not very many people are aware of what's happening in 802.11ac, which is the next generation past 11n. It's essentially channel aggregation in the 5 gigahertz bands. And it sounds like kind of an interesting, nerdy principle, except for the fact that the consumer industry, Apple in particular, are latching onto this idea as the next great thing that they can market. So we're looking at very, very rapid adoption of 11ac over the next couple of years, which will lower the cost structure even further. The second point that I wanted to make is that a lot of people have thought about Wi-Fi as kind of that horrible hotspot experience you have in the airport where you have to go through the splash page and sign on, and you probably don't have a subscription to whoever they've got offering in the airport, that whole thing. You can make that all go away tomorrow if you're an operator who wants to move aggressively. You can provide seamless authentication over Wi-Fi, and you can provide seamless integration with the back end of your network, if you're a mobile operator, by using the existing standards. There is work being done in the standards bodies to facilitate roaming in the cellular sense of the term, and that will come over the next couple of years. But we have operators moving quickly to deploy this so that it is exactly the same experience over Wi-Fi that you get over cellular, and it allows the data traffic, for which they're getting very low marginal revenue, to go over this best efforts network and completely change their perspective on how much spectrum they need to continue to provide high quality of service. So, oops, we moved one too fast. If I can go back to my last slide. There we go. So the third reason why Wi-Fi is worth considering is you don't have to believe me, a vendor of Wi-Fi. If you just go look around the world, you see very clearly the truth of a statement that some of you may have heard, the William Gibson quote, "The future's already here, it's just unevenly distributed." And as is true in wireless very often, it's arrived first in Tokyo. We have a customer there, KDDI, which has about 33 million subscribers, and they are deploying by early next year 120,000 small cells in Tokyo that happen to have Wi-Fi as their technology. And we've just learned through planning work with them that that's actually part 1 of 3. So they expect to have something on the order of 250,000 small cells in the metro area of Tokyo by the time they're done with this project. We have a number of other operators that are moving forward rapidly, and one of the main themes that you see in this environment is the idea of a land grab. Whether it's indoors or outdoors, the high-density environments where you see lots of mobile device users are all subject to the same constraints that led to neutral host systems in the DAS business you heard about. And that is that venue owners and municipalities only want to see one network. And in fact, they don't even want to have to look at that one. So what you'll see moving forward is a lot of work done to get Wi-Fi out there because it lets you take control of that real estate as an operator or as a wholesale operator that will then sell it on to multiple mobile operators. And you'll also see integration of Wi-Fi with technologies like others you'll hear about today, and we'll see that moving forward in the next couple of years. Thanks.
Great, thank you. Next question for Jim Seymour. Jim, Alcatel-Lucent is a large established vendor of network equipment, including traditional microcells. How is a company like Alcatel-Lucent approaching the small cell space?
Right, thank you. So Alcatel-Lucent's approach to small cells, as we get the screen up here, is to have a full suite of solutions because there's no one single small cell solution that meets all of the needs in the market. So we've started with the more femto types of cells. We call it the home cell, which provides low power, around 20 milliwatts, 4 to 8 users, growing that to an enterprise solution, 100 milliwatts and 8 to 64 users, growing that further to provide indoor venue type of coverage for malls, museums with around 250 milliwatts, and then eventually growing that to ruggedized outdoor solutions that can support MIMO and 1 to 2 watts. And for the outdoor solutions, the focus there is really for capacity offload of the macro. But one thing that we're really excited about is the work we've been doing on our light radio solutions based on the Cube, which we introduced this past February at Mobile World Congress. The Cube is an device that integrates the antenna and the remote radio head functionalities into a small device around 2.5 inches on the side. So all of the amplifier, filtering, radio, and antenna capabilities are in this Cube, which we can now use to put in places where it's hard to put some of the bigger small cells, as well as we can use that as a building block to build very innovative small cell solutions. We can use an array of these cubes in, like one of the pictures here shows, a 2x4 array of cubes that can now do advanced beamforming and MIMO capabilities. And we've seen by doing this, we can actually get very good outdoor to indoor coverage. By focusing beams into windows of buildings, we can provide very good indoor coverage from the outside. All of our solutions here, we have evolutions to support multi-technology and multi-band, because when the operator goes through the effort of getting the zoning and backhaul for these small cells, we really want to leverage the maximum amount of capacity that we can out of these, so they'll support 3G, LTE, and Wi-Fi. And the other thing I wanted to point out is, while LTE is already a flat network, removing things like the RNC, on the 3G side, we focused on the IUH architecture, which flattens the network and can allow the 3G network to scale to many of these small cells, as well as we can leverage the TR69 management capabilities to be able to manage the solutions as we grow. Because the need for doing self-optimization is critical when we have these large number of nodes, which I'm trying to move to the next slide. There we go. Which is my next point, which is self-optimizing networks is absolutely critical for small cells. To manage them for both LTE and 3G, from auto neighborless management, cell ID, and plug-and-play capabilities, all the way up to being able to manage the heterogeneous network. We're going to need to deploy these small cells in the same carrier as the macro. So the focus on the Sun work that we're doing now is really to be able to provide for both 3G and LTE the ability to put these small cells in the same carrier as the macro and get the most out of them. And with that, I'm out of time.
Great. Thank you very much. Rupert, so we're down to you, sort of at the secret sauce and everything. As the maker of silicon for various small cell products, can you speak to the possibility of serving multiple providers' subscribers from a single device?
Good morning, everyone. So I'm Rupert Baines, VP of Marketing with Picochip. I'm also here with a slightly different head in that I'm an officer of the Femto Forum, which is the industry association to help support small cell activity. That includes technology development, promotions. It also includes some regulatory work. So if any of you are interested in this, please go to the forum website, get involved. The next forum plenary and conference is in San Diego at the beginning of December. So everyone who's here, I'm sure it would be well worthwhile finding out about that and coming down to the public conference or the member sessions of the plenary. And certainly, given we are here at the FCC, if there are any regulatory topics, I'd be happy to take those offline and we can point to best practices and what's happening around the world. Picochip, as a company, we make the technology which is in most of these femtocells, most of these small cells. Alcatel-Lucent is an esteemed customer, so some of the products over there, ranging from the residential, enterprise, up into the metro cell. So some of these already shipping in volume to carriers around the world. Stephen mentioned about the Wi-Fi cost curves, and earlier we heard about Moore's Law. And of course, the same thing applies in technology, in semiconductors. If you can integrate it, you can make it cheaper. You ride that cost curve as the volumes increase. And there's no reason in principle why a femtocell should cost anything more than a Wi-Fi access point. The number of transistors, baseband plus a radio, a plastic shell, a connector, they're the same. So here's an example of a current generation femtocell. It's a USB stick. It plugs into your computer, plugs into your router. That is a complete 3G base station and large chunks of the core network as a USB key. There are other larger devices as well, enterprise, metro, even rural, to deploy coverage holes. Again, Stephen mentioned William Gibson's quote. Asia is the place to look at. SK Telecom has a huge deployment for capacity in Korea. Korea has wonderful cellular service, but it's full to bursting. Everyone there uses broadband everywhere. So they are deploying metro femtocells in a very aggressive way. A slightly different example would be SoftBank in Japan, who are using femtocells in rural areas for NOT spots, just to give coverage. So finally, to answer the question, is it possible? Femtocells are key to one operator. So if you have national roaming, then yes, it's certainly possible. Otherwise, you can do Velcro integration, putting two femtocells in one box. But a femtocell does belong to one operator. It is in licensed spectrum. So one femtocell is in one spectrum for one operator. And unless you have national roaming at the regulatory layer, then you can't share. And that's a contrast to some other technologies.
Great, thank you, Rupert. Let's follow up on, let's explore that a little bit more, the subject of multiple operators using the same femtocell. Just from a technical standpoint, Jay, what would be the technical challenges with putting multiple operator support in a single femtocell?
First of all, it starts exactly with what Rupert says, which is you have different operators with often non-contiguous blocks of spectrum, often using, at least with 3G, different technologies. Some might be using CDMA 2000, some might be using UMTS. So as you said, really the best approach right now would be basically to sort of, to use his term, Velcro things together. Now you could put them all in one box, but really it is one femtocell or one BTS per operator.
I just wanted to remind people that Marasha is standing in the back with cards if you have any questions as we sort of move to the less structured part of of the morning. I'd like to ask Keith whether you could speak to the cost and capacity differences between small cells versus DAS.
We're still in a kind of early stage when it comes to small cells, at least from a macro level deployment. And macro, I mean in terms of the kind of environments that we generally put DAS. Stadiums, convention centers, those type of places. We really haven't seen enough maybe of the movement towards small cell, picocell, and that kind of environment. I mean, one of the benefits that we bring in terms of a DAS or any of the DAS equipment providers is generally a broadband radio. So I'm able to cover with a single radio head 65 megahertz worth of spectrum. So 850, 1900, cover the entire band. So I can bring all the operators through one radio head. So I get that shared economics in terms of a DAS system that, as was mentioned, at least in a Pico world, and at least as we look at, sort of Pico, yes, I can put multiple base stations, multiple operators, but they're each one is perhaps a different blade. It's almost an equivalent, base station that's being deployed. Again, our ability is, with the DAS system is really to be able to provide multiple operators the shared economics of a deployment. And it's back to, even from a venue point of view, the whole idea from a venue perspective, I mean, putting multiple devices up there on the wall is also sometimes a painful thing to do. Aesthetics and others that, need to be sort of considered. So, again, from even just an deployment point of view, having a multi-operator system is a much more appropriate approach in many venues.
Rupert, you had a comment?
I was going to say, I think the advantage of DAS is that it is this multi-operator thing, but what you're essentially doing is moving a fixed amount of capacity around more efficiently. The Contella example I mentioned in Korea, what they're actually doing is they're removing or replacing DAS with those femto nodes. So every radio head that was previously the output of their DAS system, that radio head is being removed and changed into a femtocell for capacity purposes, because their problem is not moving the radio around, it's adding in 10, 100 nodes within one building. So the precedent is there in Korea for changing from the two.
Just a comment from the Wi-Fi world perspective. For a couple of years now, we've been producing dual band products that have both 2.4 and 5 gigahertz electronics and antennas, and it's all integrated, and it's much closer than just Velcro. So I think, just to give Rupert and his organization something to do next, it would be very appropriate to think about having multiple technologies supported in a femtocell over time. It's just a matter of working with the operators to understand that as they cooperate with each other when they park their base stations up against a DAS, they need to learn to cooperate with each other when they operate remotely through partitioned EMS kind of access to these multifunction devices, which is something we're doing with Wi-Fi now. They can distribute that cooperation down to an active end node with the electronics to support it. It'll take a little while for the industry to get there, but I think that's certainly possible based on the Wi-Fi example.
Thank you. We're conferring.
Trying to figure out the handwriting. So a question from the audience. Can the panel comment on the readiness of small cell solutions to handle mobility between small base stations and then into interior and exterior macro networks? Into the exterior macro network. It says standards are emerging, but when will they be complete?
So our current solution, working, and both the Airwalk Enterprise and our residential femto feed into the same femto service manager. Right now we support hand out to the macro and then very efficient idle rove in and out. The enterprise units can do soft handoff between enterprise units. The one piece that's still missing, I think my colleagues probably would agree, is the ability to soft hand in to the network. Once you get that, then the problem of being able to operate co-channel really goes away. That's going to need both technology and standards changes. But once you have that, then these things really are totally integrated elements. And then a lot of the issues with interference between macros and femtos go away.
Jim?
Yeah, and just to add to that, What we can do in the meantime, while we're waiting for the soft handover capabilities, is sort of interference avoidance techniques on the 3G side. The ability, if you have an operator that has multiple carriers, then you can manage the carrier, that the users are on, so that when they're in the interference zones, they get onto the macro-only carrier, and then they are just on the Metro Cell shared carrier solutions when they're not in the interference zones. And then that's mainly on a 3G problem. On the LTE side, because it's OFDM, there's ways to manage the interference, and we've seen even with Release 8 LTE, we can put these small cell solutions in the same carrier as the macro and be able to provide significant capacity offload. And there is evolution in Release 10 and Release 11 to improve that even further with things like enhanced intercell interference coordination and eventually coordinated multipoint to turn that interference into useful signal for the user.
Stephen, do you want to comment on the advantages of Wi-Fi over femtocells? Certainly, handoff might be an issue. Maybe you can comment on the possibility of handing off from Wi-Fi to macro networks.
Sure. And we hasten to point out to people who kind of start with, and no offense, the question of Wi-Fi versus something else. Because what we see when we talk to the mobile operator network engineering teams is they're using an AND equation. The exponential rise in traffic that we're all aware of, if you plot that on a chart and then look at what they can do about capacity, whether it's data capacity or voice capacity, against all of that, every addition they make is linear, and it might buy them another 6 months, another year, and they look at that curve and they're not sure what they're going to do next. So their thinking in the main is about using every one of these tools for the right job everywhere they can. So that being said, right now Wi-Fi is being used primarily in the minds of these operators who are moving aggressively with it for data offload, because that is what, as you saw in the chairman's remarks, that is what's driving the multiples of capacity consumption. Voice calls themselves will be fine if you can get some of that data off onto networks that were designed for very high capacity packet traffic. So today the mobile operators are looking for just best efforts offload of that data traffic. They're not even really particularly worried about having session continuity for your data connection in between the 3G network and Wi-Fi. That will come as phase 2. They're also, as you can imagine, not particularly keen on seeing voice over Wi-Fi happen because those kinds of applications, unless they're under their own control, tend to take away their most rich revenue source. So that's probably phase 3. We are doing some integrations with a lot of PBX vendors in the enterprise space, where the spectrum is sort of more under, the business model is more under an enterprise's control. And so you will see a lot of, I think, resurgence in the fixed mobile convergence ideas that were sort of stillborn over the last few years riding onto Wi-Fi. Now, the biggest issue actually when it comes to cellular and Wi-Fi interop from a session continuity perspective is not the standards behind any of these protocols, it's the mobile devices themselves, because they tend to have very inexpensive Wi-Fi, and the designers of the chipsets and the drivers that are being used didn't really think hard about the fact that you'd want to do cell-to-cell handoff very quickly. So the handset guys have some catching up to do on that.
Thanks, Keith. A sort of related question anyway. Are there environments in which small cells and DAS complement each other, or are they mutually exclusive strategies?
No, we absolutely believe that it's the AND function, as you talked about. I mean, it really does come down to use a network of networks, the hetero, network. The idea that absolutely. One of the World Series stadiums, it was basically set up that about half the capacity that's going out of that facility goes through Wi-Fi, and that's really what you need. You need to have the capability of using whatever the best network is at that point in time. So whether it be a 2G, 3G, 4G, whether it be Wi-Fi, whether it be next generation, whatever, I think we've got to be able to bring those tools to our wireless operators and to our end users. So absolutely, it's very complementary. Our PicoCell, which is sitting on the table over there, the outdoor PicoCell, has built into it both a combination of 4G, LTE, and Wi-Fi. Again, with the idea that operators want to deploy both at the same time.
Great. Another question from the audience, maybe best suited for Jim. Network optimization remains a major challenge for macro networks to maintain quality of service to the customers. Why should we expect self-optimizing network techniques to work well in that regard?
So there's been just a lot of advances in being able to optimize the networks. Particularly, the focus has been on the LTE side, where we have a new dimension to play with now with the frequency domain in order to manage the interference between the macrocell and the metrocell solutions, okay, that we didn't have in the CDMA domain. In the CDMA domain, it's still going to be a challenge, but like I said, we are working on techniques that it really becomes more of an interference avoidance problem that you have to solve, as opposed to, even with soft handover, there can be challenges between the macro and the small cell networks if, for instance, the latency and jitter that's involved in the metro solution is not quite as good as the macro, because, the backhaul that you have to use for the metro cells, a lot of times we don't have the option to have as good a backhaul there. And so because of that jitter and latency, you may even still have challenges with supporting soft handover between the two layers. And so that's why, our focus has really turned towards the interference avoiding techniques and doing segmentation of traffic, the more real-time traffic that needs to be managed, handovers between these two layers, keep that on a dedicated macro carrier, and then manage the more best effort types of data on the shared carrier, which can handle the latency in doing the handover.
Thank you.
If I can make one other observation. Yeah. Over the recent years, one of the biggest advantages, there's a saying that you can't manage if you can't measure. So along with all this technology has been much better abilities to measure how the networks are working so that they can be self-adaptive and self-learn. Obviously, just from as I keep telling people, no human being can manage a 500,000 femtocell network. So these things, we're being forced to develop self-optimizing, self-managing systems. Otherwise, it just becomes a problem that you really can't handle.
If I could add just one more thing, the good news is the LTE guys are kind of wrestling with a lot of these self-organizing concepts at the beginning of the life cycle. We in the Wi-Fi world have been at that for some time, and the good news is they actually work at very large numbers if you build them correctly, so hang in there for that.
So a related question on that, Stephen, from the audience says capacity of Wi-Fi has suffered in multi-user environments due to latency increases. How are standards evolving to recognize the use of Wi-Fi as a common technology?
Latency in a Wi-Fi environment is actually more just a matter of contention, so you end up waiting for your turn a little bit longer. Mm-hmm. Part of the issue there is most of the Wi-Fi networks that we've all experienced in public venues were not very well built because the hotspot business model never really made a lot of financial sense all by itself. Even mobile operator-sponsored hotspots tend to be a bit underpowered. And the good news is that, and we are kind of a case in point of that, if you'll forgive me a little advertising for Ruckus and the whole adaptive antenna thing, we can deliver much more capacity in a given area, given smart Wi-Fi, than is possible with 11G and a fairly underpowered network. So you'll see a lot different class of Wi-Fi in these public spaces over time. Stadium deployments are a good example of this, where if you don't deploy them carefully, all the APs can see each other, so you end up having effectively the capacity of one AP in the whole stadium. And that's not obviously going to be anywhere near enough for 60,000 people with smartphones. So the way in which Wi-Fi is being deployed is rapidly advancing as well.
Rupert, we've left you off the hook for a little bit, so we're coming back. I'm going to drive back on the question of multiple carrier femtos and just ask how hard would it be to develop one? What would the hurdles be?
As Jay mentioned, it does depend. I mean, in a US context, you've got CDMA and WCDMA. So those are fundamentally different technologies. You can make dual mode, but it's the same as GSM and WCDMA. It'll be two modems in one box, talking to two different networks over two different protocols. There's no sensible commonality beyond sharing a plastic shell. In other markets where you have 4 or 5 operators all using WCDMA, then it is possible, and there are cases where it's happening, and that is purely a roaming situation, that an Orange customer will see the T-Mobile base station, it has a better signal, they have a commercial relationship, and it'll hand over and it'll use that better signal. So you've sort of got, it's a little bit binary. It's either almost essentially impossible, or it becomes trivial if you've got the commercial relationships. And to take a US example, I'm not aware that Sprint and Verizon have any national roaming agreements. They don't talk to each other. There's no particular reason why Sprint should want to help a Verizon customer or vice versa. So they're not going to do it for commercial reasons. Technically, it would just drop out, as Stephen said, much like you can do on Wi-Fi. Doesn't matter who your ISP is, you can use the same Wi-Fi node. Technically, you can do it very easily. It's a commercial or perhaps a regulatory issue. So layer 8 and 9 in the protocol stack, not layer 1 and 2.
Well, but following up a little bit on that, from a commercial perspective, it seems like we're moving towards LTE convergence.
Yes.
And will that, what will the impact of that be?
As I said, in that case, it becomes completely trivial. You have Light Squared as an LTE operator with a neutral hosted wholesale business model is installing LTE femtocells, by definition, dropping out of their business model, dropping out of their raison d'etre. It will support every operator. They have a roaming agreement, and their desire is for that to be as many as possible. So it will happen almost automatically, because that's how they're building their network. That's why they're building a network. But in the 3G context, we don't have any wholesale wireless operators in that sense.
But perhaps if you, to think of it a different way, if you went to a Walmart and purchased a small cell for your house, do you envision having the possibility of having it virtualized for every possible network, sort of that reverse side of that question, so that you could then, over the internet, then have it optimized for your particular carrier?
I mean, we've done a technology demonstrator that showed that. So technically, that is certainly possible, but it comes back to the business model. Most femtocells in most markets are subsidized by an operator, just like many handsets are, and AT&T has no motivation to. AT&T has a motivation to get AT&T femtocells into people's homes, and they will do that because it's their device to serve their customers. I'm not sure I know of anyone who's actually deploying white label generic femtocells that could support any operator. Just like you don't get many unlocked handsets out there. It's trivial, but most consumers would prefer to buy a subsidized device which is tied into an operator.
Let's explore that. Oh, go ahead, Jim.
One thing that is not trivial from the business case perspective is the fact that there's still a lot of different bands out there. Right. I mean, even in the U.S., there's 700, 850, 1900, AWS, 2.6. That adds costs, okay, too, because as was mentioned here, still from the amplifier perspective, covering 65 megahertz of spectrum is sort of where we're at these days. We're trying to get further than that in the future to make it wider band. But, the bands as opposed to the technology, we're even working on technologies, system on a chip that can do UMTS and LTE. So from technology, maybe it's not even that challenging, but the bands are definitely the things that make it the biggest challenge.
Yes.
And if I can make one comment, we're talking right now only about the physical layer, but there's all this other things necessary to manage a femtocell. For example, Sprint versus Verizon versus AT&T. Things have to go to their femto service manager through the internet, through their tunnels, into their secure core. So we're focusing on the physical layer, but just imagine this: you go and change from, say, Verizon to Sprint. Okay, now the tunnel has to be set up into, say, Verizon's core versus Sprint's core.
It's all doable. We're doing it.
Yeah, I know, but it's highly non-trivial.
And as I say, we've done it. Taking the point about bands, in most of the world that becomes much easier. US is a trickier challenge. But we demoed that, and that did involve invoking different tunnels to go to different security gateways. That's like saying, you can connect to a different ISP. That's possible, but the bands thing is hardware and is hard.
Yeah, I wanted to ask a similar question about band support for DAS, distributed antenna systems. Keith, can you comment on, are there challenges, are there limitations of the number of bands and the number of technologies that a DAS might be able to support relative to a macro cell?
You know, the approach that we've taken, and that all the, basically all the operators that, have spectrum have used, whatever bands are appropriate. And, DAS from UHF to VHF all the way up to, 2.6. I mean, we cover all those bands. And you're right. I mean, in different countries, there's different approaches. So, in Europe, we obviously cover the European bands. In South America, we're covering a combination of what we have here in North America and Europe. So, no, there's really not a limitation in terms of which bands can be covered. It's just a matter of building the right amplifiers, the right filtering technologies, and the right antennas at the end of the day. So we're covering them all.
Is there a difference in cost between a macro cell and a DAS system in terms of the number of customers that can be covered, or the amount of area that can be covered? Is that?
It comes down to what's the transmit power that you're putting out of the antenna in terms of, or out of the DAS system. I mean, we have a combination of high power, 20 watt, which gives you a fairly significant amount of coverage. You're generally putting a full base station worth of equipment. I think what we've got as an opportunity in the future is that base station that's being bought from Alcatel-Lucent or one of the other operators, that will get integrated into something that's smaller and could be put out closer to the end user. Obviously, that's the picocell sort of world. Mm-hmm. So I think what we're going to find is that from a capacity point of view, we have equivalency in terms of macro base stations. From a coverage, you're going to have the coverage that you need to meet the in-building requirements, and it won't be the same that you need from a macro level system. And from a cost point of view, it'll be significantly less. That on a per device level, the type of devices that we have, are significantly lower cost than a traditional base station when you get to the picocell world.
Great, thanks.
A sort of a related follow-up. If there were a new licensed band, pretending that we can do that and do it with alacrity, for small cell deployments, would that make a difference from a technical perspective in terms of enabling some of the things we've just been talking about?
Yeah, definitely from an operator point of view, the idea of having a band that could be leveraged, or even from a venue point of view, having a band that could be leveraged by that venue, I think gives a lot of interesting sort of capabilities. Obviously, some of the issues that we talked about in terms of interference management and those type of things. When you're building an in-building system, one of the biggest concerns when you're using sort of the current commercial operator spectrum is, how do I create a dominant carrier in an environment? So I need to make sure that when somebody walks by that window in that office building, they don't all of a sudden hand off to some other cell somewhere else in the network, that they stay indoors. So if you had spectrum, you had the ability to really control that dominant carrier capability in a building, it would be a phenomenal capability.
If I can just comment on that. There is the Ofcom, the UK regulator, has actually got a consultation document discussing something very similar. As part of the UK LTE license situation, which has been postponed again, unfortunately, they have got the 800 megahertz band, digital dividend, the 2.6 band, and the proposal is that a section of the 2.6 would be ring-fenced for low-power base stations explicitly and exclusively, and that there would not be an obligation for that band, there would be no obligation for national coverage, and there would be an expectation of having many, many more operators bidding. So the expectation is there will be 4 bidders for national licenses, and maybe as many as 12 who would be buying that small cell specific license.
Just one more word on the idea of additional spectrum, and this is kind of on behalf of our engineering team and them representing the engineering teams on the chipset vendors. It's often the case in a very mature spectrum market that you find a slot where you think you can eke out some capacity for a new application, but you don't actually get rid of the old tenants completely. and you think, well, technology can be used to kind of have the two things work around each other. And it's the new guys who have to do all of the accommodation in the technology. And the end result is that we spend a lot of engineering time on working around the old guys as opposed to focusing on the innovation that can propel this market forward. So the request was kind of, and if you'll forgive a cultural reference, to think more bulldoze the hutong and just get that spectrum clean if you're going to give us some new stuff. Thanks.
Great. Thank you. An interesting question from the audience that's related to our discussion. It says, we have discussed band support for small cells and their related challenges. How will small cells deal with carrier aggregation? So the idea of bonding carriers from different bands together or bonding carriers within the same band together. Are small cells going to be able to support that future technology?
I think the challenge is still just getting the bands. Once you have the capability of supporting two bands in a small cell, then doing the aggregation is really the easy part. So it still comes back to just the cost economics of being able to support bands. And again, the bands that are far apart. Like, in the future we may be able, and this is certainly a focus of our light radio work, is to be able to maybe support amplifiers that can span the high bands and ones that can span the low. But between the 7 to 900 and then the 1700 to 2.6, that's quite a challenge. Okay, but once you have the bands in there, then the carrier aggregation is the easy part.
And the protocols are there. So all the protocols are there to do inter-carrier handoffs and to manage it. So it's really just, we're just about there, I think.
Let me ask a question for Jay. How does the market for femtocells break down between residential and enterprise customers?
So there are a lot more residences, and there's also different price points. Basically, a residential femto, as was pointed out by my colleague from PicoChip, is on par with either the cost of a phone or cost of a small Wi-Fi router. I mean, it's not that much more. It also doesn't have the kind of capacity. You're talking anywhere from, say, 3 to maybe 6, 8 users or wraps. But you can see the one there. I can't see what the cost is, but it's not that much. I mean, it's less than you would pay if you bought your brand new iPhone.
Stephen, let's talk about global trends. You're on the Wi-Fi Alliance. What global trends do you see that might be instructive in the domestic market here in the U.S.?
Well, mostly people are moving faster out there than the United States operators have been, in particular as it regards to Wi-Fi. But I think a lot of innovations, as Rupert mentioned, in the license band as well, have been more aggressively pursued in other markets.
Why do you feel that is? Why are the U.S. operators moving more slowly than foreign counterparts?
Might have to take the fifth on that one. A lot of it has to do, honestly, in all seriousness, a lot of it has to do with the teledensity of the United States. And in part, it's because the other operators are seeing the problem more intensely in their markets sooner than has been the case here. So we have seen a lot of pickup in the last year with the American operators, but I think because they weren't seeing the problem quite as extremely or as starkly as some of the other operators, they're still kind of in the thinking about it stage with a little bit more introspection than they might be to their benefit. So just the simple message coming in from the outside world is get moving.
One other observation has been, though, that in the U.S., because I've traveled all along, the U.S. is less urbanized. I mean, we have a lot of space here, and that means also still in a lot of places coverage is still an issue. You go to Europe, and there it's almost exclusively capacity. You have cell sites every few hundred meters. It's really less coverage than managing interference and trying to get capacity. But the U.S. is now starting to hit the same issues. Now we have a problem of both coverage and capacity, which is making it harder.
And Rupert, in your introductory remarks, you talked about SoftBank in Japan deploying femtocells for coverage in rural areas. Do you see that as a trend that might find a home in the U.S.?
I absolutely. I think it should do. I mean, Jim mentioned about their product portfolio showing the outdoor devices, and we know of operators who are using small cells to fill in not spots and areas with bad coverage as a very places you couldn't economically serve with traditional architecture, you can address very economically, very efficiently. SoftBank is the public example, but there are a number of others in other geographies who are doing that. And I think it's, going back to the point we were just making, tele-density, sparse coverage areas where you've got a coverage solution, this can be a way of dealing with it.
If you look at where our femtocells are covered, we built a graphical tool, you can see most of them are at the cell edge. The other place we're starting to see them is in very dense urban areas where there is no dominant pilot either, where you get the situation where you have so much RF but none of it is good. So we're seeing both those. But if you look, you can almost see where's the nearest base station, and you'll see a whole cluster of femtocells right near the edge of coverage. So while they're primarily coverage solutions, they're still pulling off, millions of minutes of use and terabytes of data per month.
If you take this last discussion and then just put public safety on top of it, what would be the impact of using these various technologies for public safety communications?
So I have one observation. So at least in the US, every femtocell is GPS, has a GPS in it. So by definition, you've already got much better position location than you were doing if you're not doing phone-based GPS. So rather than having to do triangulation or any other kind of position location, if you're on the femtocell, and if you're close, you may even know not only the height, you may know where it is. So you've got a lot better localization from a public safety if you take advantage of the GPS basis of the femtocell.
Two nice examples of how femtocells can be used for public safety applications. One is in Japan after the tsunami, the other was in New Zealand, and SoftBank and Vodafone respectively, in those areas the complete telecoms infrastructure was destroyed. I mean, wireline and wireless, force 9 earthquake and 14-meter high walls of water destroyed just about everything. Central Christchurch in New Zealand, everything broke down, and what they did was they shipped in cars with a femtocell and just put the just to immediately deliver femtocell, a satellite backhaul, and they could immediately have cellular coverage that they locked initially for emergency service users only, but afterwards they were opening it out so everyone could make phone calls, let a loved one know that they were okay, as a very, very quick way of fixing the cellular networks.
What we were doing is we were working with KDDI, also in Japan. They would take a femtocell, just stick it into the shelters that they had created, and then they were either using WiMAX or even satellite just to get any kind of backhaul. And again, they had this kind of instant coverage. You could just plunk this thing down. It's this big, and it's not perfect, but after a disaster, when all the cell sites were gone, femtocells in many cases were the only way to maintain normal cellular communication.
I guess I would just add to it. I mean, this, having worked with many public safety agencies over the years, I mean, clearly it's one that how do we provide them with the best possible communication system? So whether it's being their own dedicated network or giving them access to commercial networks, I think that's something that, from a policy, from a society point of view, we need to work through those issues, whether it be on a DAS system, a PICO system, a Wi-Fi, or a femto. I think we need to work through and understand how to make sure that public safety has what they need in terms of communications systems.
And doing so might free up a bunch more spectrum that you could use, actually, based on the ample allocations for most public safety networks in the United States in particular.
Great, thank you. We need to take a moment. I think we're near the point where we should be breaking for lunch. We have time, I think, for one more question, and Tom and I just need to decide we're going to get one from the floor.
Yeah, that's that one. Let's go with this one. What do the panelists and the FCC, so I guess we have to answer this as well, think about the possibility of using TV white spaces for small cells or for Wi-Fi? We think it's great, by the way.
You have a little bit of a challenge in terms of the propagation of the spectrum. It's great for coverage, not so good for capacity, just because it goes so far.
Anyone else?
Yeah, I guess I would just say that, it really does come down to, you're right, how do you want to use the spectrum? What are the applications? I mean, spectrum, generally is something that can be applied in certain areas under certain conditions with the right kind of filtering antennas and other things. So, understanding, you're right, what the applications are. White space clearly has a role in providing broadband capabilities.
Hey, Keith, that's the last word. Thank you very much.
Great.
Thank you. Thanks for
Appreciate it.
coming.
And I just want to remind everybody, we do have a lunchtime speaker, so we're slated to start at 12:30, so that gives us 20 minutes instead of 15 minutes to go grab lunch. If you go to the courtyard, CY level on the elevators, there are two, go through the courtyard, there are two cafeterias there. You can grab your lunch and be back here at 12:30. Thank you.
Excuse me, everyone. As we continue into our chat and chew part of the day, I wanted to just briefly introduce our next speaker, Ed Cantwell, who's the Senior Vice President of West Wireless Health Institute. West Wireless' mission is to lower healthcare costs through technology and innovation. And Ed has kindly agreed to talk to us today about the application of wireless as mission-critical technologies in the healthcare environment. So Ed, thank you very much. The slides will be coming up.
First, I want to thank the FCC for the opportunity to shift gears a bit and talk about the application of the wonderful things that the folks in this room can bring to bear. I am with the West Wireless Health Institute. I know a number of you probably have never heard of the Institute, but it's a wonderful organization whose mission is to lower the cost of healthcare. So you also probably have not heard in the same vein, if I can bring the slide up, the words medical grade and wireless. It's usually not used together, and very seldom do you hear the term utility attached as well. So the combination of the four words has a significant meaning as it relates to the use of wireless in healthcare. The West Wireless Health Institute, as Tom Wheeler rightfully pointed out, is a private initiative with one goal in mind, and that's to lower the cost of healthcare. There is a belief by Gary and Mary West that wireless holds the key to lowering the cost of health care via the ability for what's called infrastructure independence, meaning you can achieve your health care whenever, wherever you want, whenever you want. So my job in the Institute is to lead a project towards that goal. So if you look at the description, I would like to pose to the audience, there's no other vertical market in the world where the use of wireless is denser, more mission critical, and more life critical than in a hospital. You want to talk about capacity in limited or confined areas, look at an ICU in a hospital. You want to talk about the demand for spectrum, just do a poll of every clinical medical device manufacturer and look at their roadmap in terms of wireless enabling their products. You want to look at exponential growth in wireless data services, look at the bandwidth consumed wireless in a hospital. I contend the healthcare vertical may be one of the only growth verticals for our wireless ecosystem over the next 10 years as wireless voice continues to be commoditized. And one where wireless data coverage is so vitally important, because the reason you need wireless in the hospital is you absolutely have to have it to push patients out of the hospital. So with ubiquity being the key. So we at the Institute are strong advocates of the small cell architecture. And you'll see we're trying to put our money where our mouth is here in a second. So we want to be strong supporters both from a policy point of view, an architecture point of view, and a technology point of view. So if you were a hospital CIO, watch out, because look at what's coming at you. Across every spectrum, whether it's mission critical, life critical, consumer, our healthcare and our hospital ecosystem is being flooded with wireless devices. I happen to have survived the decade from hell from 2000 to date by deploying in-building wireless in hospitals was a key market, and I think I have my job because I stood up and after deploying in about 100 hospitals, made the observation at a forum that it's the wild, wild west of wireless in hospitals. Little did I know that I would be working for Gary West, and my mission is to solve this wild, wild west. So what we're trying to do is harness the power by making a medical grade wireless utility. So it is a non-for-profit. We are strictly non-for-profit, fiercely independent, hospital-led. So unlike the folks in the room, we're trying to lead this project by assembling the best CIOs, CTOs, biomed in healthcare today and form them into a council to create this product or this architecture. We call it a platform for wireless health. I am first starting with hospitals, but in parallel, I'm also targeting senior living facilities, which really is the surrogate for the single-family residents. So we want it to work in the hospital, but we want it also to work on the way to your house, and we want it to work in your house. The premise, the hypothesis, is that this platform is the platform for new low-cost wireless health sensors. And remember, our mission is to lower the cost of healthcare. So we want to bring down, on a price per square foot basis, the availability of innovative devices that provide a lower cost of healthcare. We want it to be ubiquitous, and we want it to be opened so that everybody has a shot to use the utility, not just the incumbents that have a near monopoly on the business. And we know that with wireless, you have to step up to a definition of assurance to make sure that you don't produce terrorists as they use the wireless, that you produce advocates. And as you can see from the architecture that I'll discuss, we are big believers in small cell architecture. So if I was a hospital CIO, and my hospital is going to open, next year or this month, I have to build 3 wireless networks in the hospital. The first is a consumer network, I call it consumer grade, that supports the patients and the public's use of wireless. And there is an expectation, just like there is for utility, plumbing, electricity, and heated and cooled air, that wireless is available. Hospitals are the most complex businesses in the world. They need wireless to operate just the business of being a hospital. And the adoption of all things wireless over the last 10 years is an example. But hold on to your hat. The number of medical grade, meaning wireless devices that have a clinical claim, is exponentially rising. So if I bring in a medical-grade, FDA-governed device, and I choose to use wireless as the transport for it, therein lies the perfect storm. So hospitals today have to take command of their wireless environment and prepare for these three. All three of these grades of networks has to have some definition of assurance. It has to be open, it has to be managed, and it has to be vendor neutral in order to accomplish the goal. So from an architecture point of view, the medical grade wireless utility in architecture form will have 4 pillars. The first is the wireless wide area network. That includes all the usual suspects, the use of PCS cellular, paging, first responder, two-way radio. In short, if it works outside, it should work inside. The second pillar is the wireless local area network. And while everybody may think about just Wi-Fi, it's much more than Wi-Fi. So in a hospital today, you have the Wi-Fi local area network, but you also have emerging room area networks, personal area networks, since we all walk around like Linus with our Bluetooth devices. And just recently, we now have a body area network with sensors actually in the body. So the hospitals need to comprehend the coexistence of these 4 local area networks among the wide area network. The one on the bottom is the location local area network, and I'm here to tell you that if achieved, can make the greatest impact. And that is knowing where assets and people are in a context-aware way. And you simply are not going to do that without the use of some form of wireless. There are many different ways to approach it. It's a very challenging problem, and it is a key focus area. The last pillar is the wireless clinical data network. Now that's a term that we coined to give visibility to the use of wireless for life-critical medical-grade use. Today in a hospital, you might have heard about the wireless medical telemetry band at 1400 megahertz. That's the only spectrum allocated to hospitals. So our nation's toughest challenge, which is the rising cost of healthcare, is not using our nation's most valuable asset, which is wireless, to approach it. So our mission is to change that and to afford the hospital a wireless clinical data network that is as robust as any wired network in any enterprise. So, but to do that, we are attacking it a little bit differently. We think that from a construction point of view, have you ever heard mechanical, electrical, plumbing when a building is being built? So part of my mission is to add a W to that. So we are somewhat covertly building a division specification for wireless so that as a hospital opens, the plumbing for wireless is built into the building so that all these wonderful pieces of equipment have a home. And as you know, part of the problem of getting wireless into the building is the nastiness that is the plumbing of it. So we're taking a very base building approach to this, and we hope to introduce to the market a division specification so that from this point on, every hospital that is built has W as a utility, just like electricity, plumbing, and heated and cooled air. So you can't utter the words medical grade without defining what it means. So this is a rough definition. You use time critical and acuity to try to separate whether a device is medical grade, enterprise grade, or consumer grade. Obviously, high time critical, high acuity should be medical grade. We think, as Tom Wheeler rightfully pointed out, a little bit scary that there's more cell phones than toothbrushes, that the consumer tsunami of wireless devices is really going to be a force. So we're working closely with the FDA to help with definitions of what should be considered medical grade versus enterprise grade versus consumer grade. And then probably the boldest thing that we're doing is trying to put forward a definition of assurance, because often you don't hear assurance when you talk about wireless. So the algorithm of assurance is going to be coverage in terms of cubic foot, signal quality in terms of the signal needed by the device against the noise environment, capacity per unit area, security, all forms, and then the fifth one comprehends the complexity of wireless, and that's certainty. And that is, what's the probability that in an ICU with 32 different wireless frequencies being deployed, that they're all going to play nice and coexist together? And because of being in San Diego, we had, we're 6 million people without power. So redundancy has come in as potentially the sixth metric. So simply, we are taking those assurance metrics, constructing a consumer grade, enterprise grade, and medical grade network as a way to, from a platform point of view, make sure that the devices in the applications that come in the hospital know which lane they're going to operate on and adhere to the laws of physics, which, as one of the earlier speakers, always wins, right? And so it's quite fascinating. The 22 CIOs and CTOs that are on our council represent what I think are best in class in the US. And it's quite intriguing and sobering to look at the use, how the wireless spectrum is used, and which frequencies over time have the ability to be the backbone of medical grade wireless. So it's we don't underestimate the challenge. We don't underestimate that we have to bring an ecosystem together to do it. But this is just an example of how complex, from a platform point of view, the multi-frequency, vendor-neutral world is inside of a hospital. So I learned long ago as a young, foolish CEO that decided to form a company in 2000 that this formula will drive all logic eventually. And that is capacity per megahertz per unit area divided by CapEx, initial CapEx, and life cycle costs. And so this has been the formula that's really hung up in building wireless, over the last 10 years. Because this is the way the CEO or the CIO looks at it, but this is the way that the carrier looks at it. What revenue do I have per megahertz, per cubic foot, per the investment to make it work? So we want to boldly socialize the concept where the frequency, whether it's licensed or unlicensed, in a hospital is a special use. And we feel there has to be, in terms of architecture and assurance, combined with innovative business models, a better utilization of both the licensed and the unlicensed spectrum. So we know, ye who leads is the leader, and we know it's easier to edit than it is to write. So we are going to propose a building-based architecture that has the flexibility to deploy the diverse set of spectrum, but in a way that meets the operating expense limitations of a hospital while delivering assurance. So a typical way to look at a hospital is you look at the campus, outside and inside, where you might have an outdoor DAS deployment as well as an in-building deployment. What base station capacity is needed to deliver the hospital as if it was a cell tower, and then how to segment the hospital from a small cell deployment. You know, I scratched out the exact definition of what a small cell was in a hospital, and to me, it's driven by capacity. So we are looking at structured cabling concepts to make sure that your equipment has a plug-and-play capability and that the coverage is taken care of from an antenna point of view. So we envision that the wide area network will have a small cell definition over time, and we also are big advocates that the proper use of Wi-Fi, especially done with assurance of mind, is important. And we also know that the networks are getting even smaller in the room, around the body, and in the body. So it's a very holistic approach, and it's one that tries to strike the compromise between the business challenges of it, the technical challenges of it, and the healthcare challenge. And quite frankly, we're about 8 months into this. We have the council. We have version 1 of the architecture. If you contact me, I'll be happy to talk to you about it. We've engaged with the FDA and the FCC. We are now in the process of engaging with the national carriers, the equipment providers they use, and then in parallel, talking to the thousands of the devices that want inside the hospital. So it's a very challenging project, but one whose time is right. So I appreciate the opportunity to share it with you. Yeah, sure.
Why don't we do maybe 5 to 10 minutes of questions while the people come back for the next panel? Hi.
I think this is a theme that will come back, particularly on the panel. But this notion of was raised in the last panel on a dedicated band for small cells, a license band for small cells. Is that something that, you know, could provide sort of volume here? You're looking for at, you know, a band that is sort of licensed in a way where the hospital basically, you know, can essentially put at the level of insurance protection within the four corners.
Yes, so the question was, in essence, does the medical grade wireless utility embrace the concept of a license band, you know, for use? And the answer is absolutely yes. The 1400 megahertz band is an example of this, but it is a grossly underutilized frequency because it does not have the power of the Wi-Fi economics or LTE economics. So just as an example, picture the power of, on a floor basis or every other floor basis, the luxury of having a dedicated LTE, and I don't care what you call it, whether you call it a picocell, a femtocell, a macrocell, or a base station. It is simply the use of that capacity over a defined area with capacity in mind. And if I'm a telemetry patient, I could have a telemetry wireless device that could give me absolute assurance in the hospital, plus stay with me on my way to home. So we are big proponents of that, but we also think that we can work with the carriers to properly deploy that asset in a hospital under a business model that makes sense for everybody. You buy millions of dollars worth of Wi-Fi infrastructure to use that spectrum. There's no reason why you can't do the same, especially as LTE starts to proliferate. Yes, sir. Yeah, so there's perhaps the most intriguing challenge that we're facing is the dilemma that when the FDA gives a FDA clearance for a medical grade wireless device, it's on the onus of the device manufacturer, if they choose to use wireless, to ensure that the wireless behaves the way it's supposed to behave. So because of the lack of protected spectrum, where do device manufacturers go? They go to the unlicensed band. and then they turn back to the hospital and say, well, if you want to use my telemetry, you have to assure me that I have a neg 55 Wi-Fi deployment, and I get first dibs. But the problem is there's 30 other dibs, right? So we're trying to detangle the spaghetti and make sure that the wireless frequencies are no different than a lane of a highway. You have to know who's allowed to be on it, how fast they can go, and how many cars can be on it. Other questions?
Thank you. Along the lines of innovative business models, we are aware that there are investors who are interested in installing small cell networks integrated with smart grid technology in building. One of the biggest problems they have is getting permission to do so with those who own and operate the buildings. Would the hospitals that you represent and that you're focused on be willing to consider partnering potentially with those interested in funding small cell development or installation and management in your facilities at their cost, if they could make arrangements with you to do so?
Absolutely, but you have to step up to respect the challenge that is the building, and that's the missing link. Is wireless is not showing up in our buildings as plumbing, electricity, and heated and cooled air. So that's why we're taking a division approach to it. But I'm here to tell you that wireless is the one utility that can have a profound impact on every other utility. So I think that's why we're trying to do this as a platform architecture play, not as a vendor specific, you got to use this vendor or that vendor. Because I think buildings should be plumbed theoretically to deliver in some level of assurance any frequency, to include 60 gigahertz. So it's a philosophical approach. Okay. Thank you.
Thank you, Ed. And we'd like to ask the panelists for the second panel to come up and take your spots, please.
All right, thank you for that really interesting talk. We're going to start the second panel, which is on business models. I'm John Leibovitz. I'm Deputy Chief in the Wireless Bureau here at the FCC.
And I'm Paul Desai. I run the Office of Strategic Planning.
And so I think the format will follow be similar to the first panel. We're going to ask, everyone has a question, which they'll address, and we'll go down the line asking the questions, about 3 minutes per question, and there are some slides, I understand, and then we'll get into some give and take, and if people have questions, they should hail a card and pass it up to the front. Paul, do you want to start?
Are you going to introduce? Do you want to introduce?
Oh, yeah. Why don't you go?
Okay. So we're going to start with Lynn Lansdale, who's the Vice President of Strategic Business Services at Avalon Bay. So maybe we'll just introduce people as they do their presentations. So Lynn, why don't we start with you? So you're in the residential real estate business largely. Can you talk a little bit about how indoor wireless factors into your value proposition for your tenants?
Sure. Do you want me to do the slides in conjunction with this, answering this question? Sure. Okay. Well, in order to understand that, let me talk a little bit about what our business is. We manage and develop, build, redevelop, and sell and buy apartment communities, all rentals. No for sale, no condos, it's all rentals. We have about 55,000 apartments in the United States, and primarily urban markets like D.C., Boston, New York, San Diego, San Francisco. And we have a mix of high-rises, but also a number of garden-style communities that could encompass, many, many acres. Our rents are high. People pay us about $1,900 on average per month in rent, and our average residency is only about 18 months because typically we're the place that you live before you move out and buy your home, or the other reason for move-outs is primarily job relocation. So we have a very transient resident base. Lots of turnover in our buildings with people always moving in and always moving out. We have had some issues with cell coverage and with Wi-Fi that are important to us because it's important to our residents, obviously. Increasingly, residents move in and expect great coverage, and it's difficult for us when we can't assure them of that terrific coverage. We do offer, particularly in our newer communities, we're offering a Wi-Fi solution, primarily the hotspot solution, in our common areas and resident gathering places, pools and resident lounges and things like that. But that is not yet an absolute must-have amenity that we offer for our residents, and we do it on a case-by-case basis in existing communities. So new construction, we're typically adding Wi-Fi in all instances, but existing communities, we've not gone back and put it in everywhere. We've had some real challenges in the area of both cell coverage and Wi-Fi coverage for our residents. The public safety reception requirements have been a challenge for us, particularly when they come as a surprise, and we feel like we're being held hostage by the local jurisdiction and we can't get a certificate of occupancy because suddenly these new public safety requirements have been placed on us. There can be a very long planning cycle. It could be over 5 years, sometimes 8 years between when we first start designing our building and when we actually have our first residents moving in. So we don't like surprises in the way of new requirements, particularly that require infrastructure on our part. I think, generally speaking, we would prefer that the carriers address the coverage issues that we faced in our buildings for our customers. Because our customer base can be somewhat fractured, we may have 300 people living in a building. Half of that building may not get good coverage, and of that half of the building, there may be 3 or 4 different carriers represented. So we've not had much success in getting help from the carriers and helping us solve this problem. And as an industry, we're not prepared to manage bandwidth. We don't necessarily understand the technology. We don't have the resources on site to do a good job of it. So it's been a real challenge for us, and we're anxious for a solution, but we don't have one.
Great, thank you.
Okay, so the next panelist, thank you, Lynn. The next panelist is Robert Giuliano, who is VP and CIO with Brandywine Realty. They are a primarily commercial real estate firm, and so the question we have for you is similar. Following up on Lynn's answer, can you distinguish some of the issues you face as a developer of commercial properties, and can you speak to some of the operational and ecosystem hurdles that you face as they relate to wireless and small cells?
Absolutely. So, thank you. So let's just point somewhere. There we go. Cool. Yeah, a little bit of operational background, and again, similarly to Lynn, we have a pretty large footprint, and there are some overlaps there. About 308 properties, about 35.5 million square feet that we directly own and manage. And in addition to a tenant base, as has probably been pointed out here, that is increasingly untied to landlines, it has a wireless expectation that are both our future employees and our future tenants. We process operationally about 10,000 work orders a month entirely over cellular. Our engineering staff is entirely wireless. They very rarely show up at a wired computer. So we have both a tenant and a client issue as well as an operational issue in this space. And if you look at it, just a quick number here for you, we've gone out and spec'd out repeaters in a number of cases. We've had signal issues in buildings, and 88% of the time, they come back and say, no, that's just too expensive. And this is just from an operational point of view for our offices in those buildings, not even counting a tenant space. About 17% of our staff have reported signal strength issues, and about 14% of our staff have changed carriers because they couldn't get sufficient signal. So if you look at it, we're spending time and money operationally just getting people a working wireless signal so they can do their job. And in addition to just base provisioning, we've spent about $500,000 in the last 2 years just making those kind of changes. So if you look across the board, as a tenant, a client of a tenant, as an owner as we are, we're also a manager and a developer, we fill all these roles, but we also obviously have a customer base looks at it. Safety, we hit on that a little bit in the previous the lunchtime speech. You have a life safety issue. You have an amenity issue in that your tenants are expecting it as a utility. The expectation of both utility and ubiquity. It's a little repetitive of what we've seen today. And then operational and design issues as we build and operate the buildings. And at the bottom, if you're looking at the wider theme of today, where are the opportunities? That last row, we have risk for around safety. People like to sue deep pockets. Anybody who falls in one of our parking lots sues us. Imagine you're in one of our stairwells and can't get a signal to call 911. Complaints from tenants. We work a lot of time with the I can't get a signal, or my visitors can't get a signal. Expectation, if we don't have as good a signal as the next door neighbor building, we could potentially lose business in coming in. Operationally, we have outages. We have systems as well as operational needs. And design, it adds complexity when you go in and build a building. Lynn mentioned, the LEED certified glass. We have to look at what are the materials we use in a design point of view. Probably at the end of the day, this is the evolution of utility in one chart. Electricity, water, phone, and data are expectations. As has been mentioned, wireless is increasingly becoming an expectation there, and we need to really look to address it. It's critical to us. It's critical to our tenants. Signal management is a drain on us. It's not our core job. We really look to the carriers to do that, and we're looking for a wireless voice and data convergence. We talked about 802.11 and 3G and 4G coming together. We're looking for some leadership out of the wider community for that, and we really do not want to own bandwidth. I can't say that strongly enough.
Great. Thank you, Robert. Next we have Tom Larson, who's the VP and CTO at Externet Systems, who are a leading provider of distributed networks. Sorry, I forgot. The question we asked Tom is, how do you think the market for distributed antenna networks in the U.S. is going to evolve?
Yes, so first and foremost, we look upon what we call distributed networks, which include both distributed antenna systems, also distributed base station solutions, and also including picocells, femtocells, and Wi-Fi. And let's see if this. And a lot of it is the same challenge in terms of deploying it exists for all of these different type of technologies. And you need to be able to install it, the location of it. You need to have connectivity to either that being a DAS node or a remote radio head or a femtocell, picocell. So you're in the business of designing, owning, and operating those networks, and specifically across for multiple carriers. So some of the challenges that you just described is where we try to step in and take on that responsibility as a third party to make sure that you get coverage from multiple carriers and leveraging the different technologies that's out there. From a traditional DAS perspective, we do both indoor and outdoor solutions. And if you look at kind of where they fit into the marketplace, indoor DAS is typically somewhat larger buildings, 200,000 square feet and larger. Outdoor DAS, either one object obviously to cover the outside areas, but also in a lot of campus environments. We currently are deploying a large-scale deployment for University of Michigan, where we are looking at in excess of 500 buildings. 300 of those are greater than 10,000 square feet. So there's a lot of small buildings. Using an outdoor approach is more efficient for covering that, and also actually using femtocells and picocells in areas of small buildings that, from a cost perspective, is difficult to justify from a traditional DAS perspective. Another thing with kind of both our business and kind of from a DAS perspective is, being able to support, like I said, multiple carriers, medium to high capacity, but also being able to accommodate changing capacity. Stadiums and so forth is good examples of that, where you have peak of capacity for a short period of time, then it's pretty much nothing happening. So how could you leverage that? How could you more efficiently using those assets that you deploy from a carrier perspective? So we see a lot of momentum right now in a number of verticals, including healthcare that Ed described, higher ed, government, sports and entertainment. Is a lot going on because of just the applications that's out there, hospitalities and multi-dwelling units as well. And again, when we talk about small cell, it's kind of, what's small in it? Is it the physical area of a cell, or is it, the size of the units? Or, so we try to kind of use all those tools that's available to solve those challenges that's out there, specifically from a capacity perspective.
Thank you. Next, we have Steve Lilly. Steve is the wireless practice manager with Presidio Network Solutions, and they do a great amount of projects with Wi-Fi. So we wanted to ask Steve, similar to the question we asked Tormod, how do you think about the market size and segmentation for indoor Wi-Fi deployments?
Thank you. Well, Presidio focuses primarily on both indoor, outdoor, and when we talk about wireless, I have to be careful in this group. We actually specifically target Wi-Fi. 802.11 wireless is the technology that we spend the majority of our time with. We do spend a little bit on carrier cellular type engagements, but the majority is 802.11. In terms of the services we offer, is design, architecture, a lot of site surveys. Wi-Fi voice is a big one for us right now, perhaps because of cellular issues. We work in a lot of locations like hospitals where cellular coverage is a real challenge. So the hospitals want to be able to keep in contact with their staff the entire time. So they'll deploy a voice system overlaid on top of the Wi-Fi system. And I guess we're fortunate in that the Wi-Fi spectrum is unlicensed, so we can control that quite a bit better. You know, it takes some financials and money, but we can solve that problem usually. Another area that Wi-Fi is growing in popularity, and this also applies to healthcare and other areas, is location services. So just at the hotel the other night, I looked and Google knew my location, which I'm not sure if I like or not, but I don't have GPS. I don't have a chip embedded in the back of my neck, at least, not that I'm aware of. But location services. There's companies, Ekahau, AirScout are two leading providers, and they overlay a solution on top of the wireless network. There are also a lot of new and exciting applications that are more smartphone based, where some of the museums now are. As you move throughout the museum, you can bring up an app on the smartphone. It knows where you are. If you want to get to the King Tut exhibit, you can, either hit the thing and it'll direct you to the location. More importantly, if you need to know where the restrooms or the vending machines are, they can point you that way as well. So that's another big area for us. Guest access, everybody's familiar with that. It's ubiquitous now. So again, we do indoor and outdoor. And let me skip to the next slide. So I want to just kind of finish this. Going back to like the mid-90s was really when wireless took off. We had some pre-standard products. Speeds were really slow, but they were adequate. And we moved through the 802.11b, the 802.11a and G standards. 2003 to 2005 was really where we saw our business taking off, and we saw customers really adopting wireless in a pretty big way. Now, as we start to have the ubiquity of the mobile devices, they're everywhere. Everybody's basically, they have no choice. They're jumping on board. 802.11n has been around for about 2 years now. Speeds of 300 megabits per second, speeds of 450 megabits per second within the next few months, and speeds of 600 megabits per second by 2013, I would guess. So we're quite excited.
Great. Thank you, Steve. Next, we have Ken Falkenstein, who's the Vice President of Wireless Technology at Comcast. And Ken, maybe you can talk a little bit about Comcast's strategy for providing in-building wireless coverage for your customers.
Sure, thank you. Although we're a cable company, we've actually spent a fair amount of time and effort studying small cells in general. We've looked at licensed and unlicensed spectrum. We've performed technology analyses. We've built prototypes, and we've also looked at the economics and the markets and spent a lot of time talking to our customers. And I think our conclusion is that small cells are real, and they will be a key to solving the crunch. I think that was well established this morning, and I think we agree. It's simple physics. You get the users closer to the base station. They then are able to operate at higher levels of modulation, and and take advantage of multi-antenna technologies, higher spectral efficiency, and you're using the available spectrum better. From a pragmatic standpoint, I think the technology panel earlier covered a lot of the technical complexities, and in general, I think those are solvable. There are some pragmatic challenges, though, things like space, power, and backhaul that are challenging, particularly with mobile operators who don't have a lot of fixed line infrastructure. So, in that regard, I think there's a nice match to the cable industry and the assets that the cable companies bring to the table. We have aerial strand. That strand is powered. We run DOCSIS technology over that that's capable of very high bandwidth. We offer 100 meg service today to our residential customers, and that's only going to grow over time. And we also have a big field technical workforce. And as we move to the next slide, I think the reason why that's important comes to light a little more in that when we look at users and where they want to use their data, as was mentioned earlier, indoor is a large part of that. A lot of data is consumed either in the home or in small enterprises. We think that needs to be complemented with an outdoor solution. But when you think about the numbers of units, these are large numbers. Mobile operators are used to tens of thousands of base stations, and now we're talking hundreds of thousands or millions. There's back office challenges, but there's also feet on the street challenges. And cable's been in that space for a long time. We've got a large technical force, and so one of the things we think about is how do we complement that. So sort of the last points are, what are we doing today? Today we're very focused on Wi-Fi. We like the device ecosystem. We like the cost of entry. We think that we need to keep it simple at first, so today we're just offering it as included package. However, there's a number of opportunities in the future that we'd like to explore with mobile operators, with pay per play, and other commercial examples.
Thank you. So lastly, we have Iyad Tarazi. Iyad is the Vice President of Network Engineering at Sprint Nextel. So hopefully can offer a carrier perspective on this, wireless carrier perspective on this. So our question for you, Iyad, as a carrier, where do small cells and DAS fit into your approach to in-building connectivity?
Sure. Sprint is the third largest wireless carriers. We clearly care tremendously about customer experience, and I heard some of the panelists about people call us all the time, say, I want to use your network more. That's a great thing. We have invested in the last 5 years about 20 billion plus in 3G and billions more in partnerships for 4G. And so it's not lack of investment where you don't still get to every little corner of the United States. The real problem is when we built 3G networks, the phone used to be called the car phone. I don't know if anybody remembers that. As a matter of fact, RF engineers get to be rewarded on covering good intersections, right? There are certain states now where if you use your phone certain ways on these intersections, you go to jail. Where the traffic went now into the house, tablets made it very socially acceptable to use your smartphone and tablet right in the couch surrounded by people, on a restaurant surrounded by people. And so suddenly all the use is going indoors. So you still have to invest heavily. We've announced a network program called Network Vision, which pumps another series of billions of dollars into the network, takes us to next generation 3G and 4G, the latest investments. One of the things that distinguish Sprint is that we are trying to maintain a value package as well. So not only we want coverage, but we want the right cost structure. So can I get the clicker? I'm just not sure the best way to get to the slide. So having said all of that, small cells are extremely important to us, and they're a key part of our strategy. We now have about 500,000 femtos. To give you a perspective, how many of that? Femto Forum quantifies about 2.5 million femtos worldwide now. That give you perspective how much we've been pioneering this space. We launched the very first femto. 2007, we spent 2 years figuring out how to make it configurable out of the box and how to take the RF engineer out of the network. because ultimately that's where your cost is people like me that you want to take out. You want it to be clearly directly come from the manufacturer to the consumer. We've also launched now, or in the process of launching, an enterprise version of that. We have about 37 users now in trials. We started wanting to find 2 users, and we've had 30 volunteers, and that's moving to thousands. It allows us to add more spectrum bands. The cost structure is dramatically lower, and we have plans now to launch Pico's indoor and outdoor, to continue to invest in coverage and capacity. This is essential for us. Without it, we cannot multiply the value of spectrum. Ultimately, that's what this is about, taking the spectrum and make it more usable in more places in a very cost-effective way. The biggest challenge is that scale in so many different ways. How do you use the same spectrum? How do you share backhaul? How do you share cost structure? How do you share equipment? How do you share resources, et cetera, et cetera? And ultimately, I'll just leave you with the thought that we're pioneers in the open network space in the U.S. We've announced, as you know, a network sharing arrangement with LightSquare, and we're exploring others. And we would very much like to see infrastructure sharing develop in this space as well, because the biggest cost today in building coverage is in engineers and wires and construction, not in equipment or technology. You know, that's a shame, and we need to fix that. Thank you.
Thanks. Just following, I think there were a lot of the themes kind of introduced in the panel. Just following up on one of the things that was said, I think Tormod said about DAS being sort of established in larger venues. I think you mentioned 200,000 square feet as sort of a rule of thumb marker of some kind. And I wonder if that sort of suggests that I don't know how many millions and tens of millions of square feet there are out there in the U.S. that's less than 200 facilities that are less than 200,000 square feet, but I assume it's a fairly large market segment. Is that sort of the natural home for small cells? People care to comment on that?
Maybe I'll start. The challenge for us is that in the 3G world, this thing used to be called a repeater that fixes these problems, the smaller cells, because all you need to do is just propagate the same signal. In a capacity-constrained, spectrum-constrained world, that's not sufficient anymore. You can't just go propagate. All you're doing is just pollute the external network. For us, the technical challenge for all these smaller and mid-sized locations is you can't just go in and repeat the signal. You have to regenerate the signal from scratch, which means repeaters get naturally replaced with femtos. And that's a huge opportunity in the wireless networks.
But as between sort of the 3 solutions that we've discussed so far, the distributed networks or distributed antennas, licensed small cells, and Wi-Fi, do you have a perspective on, if you're kind of going after this middle market segment, which I think probably, some of your properties may qualify for that. Do you have a view on what the right mix of technologies ought to be?
I know we installed a distributed antenna system in one of our communities. We did it because we were forced to in order to meet the public safety requirements, and it was an after-the-fact sort of thing. I think it was about 200 grand to do it, and it was a surprise, as I said. That's not a solution that we would typically be looking towards in the future. I mean, obviously, if you put something like that in up front, it's less expensive than doing any kind of a retrofit. But again, in our industry, our customer base is so fragmented, we don't have the confidence that that distributed antenna system would necessarily solve all the problems that may exist in our building for all our different customers and their carrier situations.
So to add on to that, these places generally have cable drops, and so I think we could do a better job exploring the backhaul opportunities. And so basically, if you have a cable drop, you can have wireless offload for very, very low cost. And one of the things that I've seen in the past is with Pico cells and DAS is that it requires fiber. and that is generally more expensive than a cable modem that, we buy in very large volumes. So, one of the things we're exploring is how can we partner, leverage our cable infrastructure that's already there, the high-speed backhaul, the power that's there, and sort of just add on to the very end of that either a Wi-Fi or a cellular radio to provide service in areas that are not large and that don't justify a very large infrastructure bill.
Great, and just as a reminder, I think we have cards if anyone in the audience has questions, or if people online or watching online have questions too. Maybe answer a question, just listening to the panelists, maybe we can do some real-time problem solving here. It sounds like we got the carriers at the end who are really excited to get customers and provide coverage. We've got the two people in the middle who are really excited to install networks, and we've got the two people at the end who can't get any service. So I'm trying to understand if anyone has sort of hypotheses about kind of what's going on here.
Change seats, maybe.
Yeah, I mean, is this sort of a microcosm of the country? Like, can we look? What's it? As you listen to the carriers, or you guys listen to the property owners, look, what's the hypothesis here for what's going on?
Yeah, no, maybe. I'll take some of that. Yeah, it's not a complete answer, but I think this is a case where the technology has probably outpaced design. In an office building or an apartment building, you've got a design, it's fixed, and in many cases it's 10, 15, 20 years old, and it really isn't engineered to accept this. Cars probably turn over every few years, so you get the new plug-in, you get Wi-Fi integration with your car now, things like that. Buildings don't turn over at that rate, and so to go back and then to attempt to make a capital investment or retrofit your building to match the technology is a bit to bite off. And with the cost structure, and I certainly speak for commercial, the tenants often pay their own electric. They certainly pay their own data providers at a wire level. They have Comcast or whoever they want for cable, and so to say, okay, we're going to make this capital improvement in the building and then turn around and ask them to foot the bill is not really a tenable business relationship.
But it's not enough of a differentiator between sort of different properties. So if I'm a business, I'm trying to find somewhere to go and locate. I mean, it sounds like what you're saying is, the return on your capex in terms of persuading people to locate in your building versus someone else's, it's not there yet?
It's not there yet, and it also varies market to market. We have a mix of CBD, center city, high-rises, and the suburban office parks, so it also varies from building to building. You look at some of these where the scale and scope, a 53-story, 1 million square foot building, you have a different value scale. You've got a different economy than you do in a 3-story suburban office park building. And you also have a different tenant mix and profile. You may have a bunch of small startups in one place versus large multinational corporations in another, so you've got a different expectation of amenity and cost.
Got it.
I was going to mention, I think for us it's a challenge of scale. We really don't have the scale to generate the interest or to justify the investment. And because the problem can be so spotty, it can be one part of the building but not the other part. And so the part of the building today may have people with a certain carrier living in it, but next month those people may not be there and it may be another issue, in a different part. So it's a little overwhelming, I think, at this point for our industry to try to figure out what the right approach is, and it's almost impossible from our perspective to justify an investment in the technology or the infrastructure because we just are not certain that it's going to solve the problem for us.
Got it. Maybe.
I would say it's not just the building problem, it's the carrier problem as well. You could apply that to macro sites that cover your neighborhood. These solutions, the big solutions, are essential in many locations. However, they take a long time. They're a 1-year, 2-year planning. What happened the last 5 years with the mass adoptions of smartphones and the movement to the internet is that the consumer now has control over almost the entire wireless experience except coverage. And so there's a lot of frustration to say, why can't I make it so right here in this corner? And in essence, that's the problem that needs to be solved. There has to be some way to allow the consumer to have more control over their experience. And that's why small cells are really effective, especially if they're designed in a way to be self-configured, self-managed, consumer-friendly, using the simplest of wiring that you could possibly think of that is compatible with the right capabilities without a lot of thinking required. I think there is a need in the industry for control to the consumer over coverage and capacity, so it's no longer someone else's job.
Right.
So Steve, has Iyad just described Wi-Fi? Is that?
Well, that's why I keep coming back to. Yeah, I think the issue is the building of multiple networks indoors for coverage and capacity. Coverage is easy. Capacity is really the issue now. And we've got this great unlicensed spectrum that we're really not taking advantage of. 2.4 gig, that tends to be more of a cesspool. The 5 gig space, you know, you've opened up.
We call it the ISM band over here. That's the FCC word for a cesspool, yes.
The 5 gig in 2007, you opened up a significant chunk of spectrum there. On the Wi-Fi side, we are not taking advantage of that at any of the enterprises that I visit. And you know, I can go out today and I can buy a femtocell and drop it in my basement. Wouldn't it be really nice? My phone and all my devices already have a Wi-Fi chipset. Wouldn't it be nice if somehow there was the ability as I walked into the house just to say, okay, your Wi-Fi now, jump onto the Wi-Fi network. The enterprises we work with, it's frustrating when you walk in and they say, wow, this is great, you're doing a great wireless deployment. Is this going to make my phone work better? And I have to say, no, it's not going to do anything really for your phone unless you're browsing on the guest side. So I think enterprises would absolutely partner with the carriers if they thought there was a way where they could just partition off 15% of their wireless bandwidth and send it out to the carriers. Overnight, I think that would be a huge success.
Just something we've seen over the last few years in cable TV, and some of that I'm hoping happens is, 5-7 years ago, we would have to pay the cable provider to trench and run to our building. In the last few years, they're now coming and begging us. They're saying, what do we need to do to be in your building? I'm hoping that there is a wave building up in the wireless space where the wireless carriers are coming, saying, how do we get signal to all of your tenants? And I haven't seen that wave quite carry on, but I'm hopeful it will happen.
Ken, do you see that as, Comcast is going after sort of business customers a little bit more maybe than historically? I mean, do you see the sort of the wireless angle as part of the kind of pitch for that?
Absolutely. I think our customers are asking for high-speed internet access, wired and unwired, and I think that's how we view Wi-Fi. It's just another dimension to internet access. But if I could, I can't let the cesspool comment go. That was too fun. So we built out a Wi-Fi small cell network in Philadelphia, several thousand APs, indoor and outdoor. One of the things that we are seeing is the 2.4 spectrum is crowded. We service the Wells Fargo Center, which is a large stadium in Philadelphia, and at peak times during a game, we'll see upwards of 120 what we call rogue APs out there. These are the personal MiFi devices and all sundry sorts of things. And I think Wi-Fi can and will play a large role in offloading. I think that 2.4 challenge is going to continue. It may be worthwhile as we think through the spectrum coming down the pike, licensed versus unlicensed spectrum, and expanding in probably both of those areas. And one thought I'd like to leave the group here with is, is there a third alternative that is somewhere between licensed and unlicensed that somehow addresses the cesspool issue, yet allows ease of market entry for new entrants and new operators to get in there, something along the lines of sort of a lightly licensed. I'm not a policy guy. I don't claim to know how to solve that problem, but I think there's an opportunity there if we can think through that.
So I think that's a good, interesting point. I think it dovetails with the idea that was raised on the previous panel, and I think will come up in the next panel about if there was a sort of a dedicated small cell licensed band, would that be something that you think would somehow, stimulate the kind of, activity you're talking about? Or alternatively, the other idea that was raised on the previous panel would be taking some of the open ease of entry aspects of Wi-Fi and bringing them to the small cell space, having a multi-carrier small cell of some kind. I think you had mentioned infrastructure sharing, and of course the wireless industry has been through this a few times before, but one of the best examples is tower sharing, where it used to be every wireless carrier had their own tower, and then they realized they're not in that business and they decided to share towers. Is it conceivable that if there was some kind of device that could serve multiple providers and all of their end users and install it once and hit your entire tenant base as needed, would that be something that would be conducive to, would that stimulate more investment in this space?
So
back to the answer because that's kind of our business, right? That's what we, the concept of our business is to try to come up with an economical solution that serve multiple, users, being carriers, and it could also be, enterprise needs. And from a deployment perspective, to Eyad's point that the majority of the cost is not in the electronics anymore; it's in the labor and putting it in, and a lot of the challenges as well is there because okay, you're going from hundred thousands of sites if you kind of do the outdoor comparison to 100,000 or to millions, and same thing indoors. We talk all about small cells, but it means that you need to deploy a lot of equipment in a lot of places. And so I think the idea you mentioned about a dedicated spectrum is interesting, and from a number of perspectives, as we design and deploy networks today, one of the major challenges from a cost perspective is that we need to, I think Keith mentioned earlier, we need to be dominant relative to what's coming from the outside, and competing with that to be able to truly offload the network. So having something that could be more contained and also could maybe also provide some additional value to the enterprise or the building owners in that respect. Because I think that's kind of, you asked a little bit earlier about between the carriers and the building owners, and we kind of in the middle here. I think that a lot of it is for a building owner or enterprise to realize the value of wireless. I don't think it's good models out there today to really figure it out, and I think same thing on the carrier side is, okay, going from more of a voice-centric business model to a data-centric business model, the only thing they know is that been a tremendous growth, and how do I monetize it, and so I think it's a lot of around that as well. So
I guess I would only add that the key is the device ecosystem, right? You've got to have these chips in all the devices people want to use to get the offload, and I think the concept of a non-exclusive access to that spectrum, I think, will be key to drive the device ecosystem so that these radios show up in cameras and portable game units and, not just tablets and smartphones. But I think that could be, I think there's a lot of attractive opportunities in that regard.
Yeah, no, just coming back to the spectrum question, I think our objective is to maximize the use of spectrum. I think there is more data usage that we can create with any spectrum we open up and enable in the network. I think everybody's seen that. Literally, the minute we add another carrier in the network, we see it getting gobbled up in odd hours of the evening. People use the network. So what we've been focused on is figuring out how to use the same macro network spectrum with femtos and picos so that we avoid the, stranded spectrum problem. And I think that with LTE now, the economics and efficiency of the network looks a lot like Wi-Fi as well. Although Wi-Fi as well is looking more and more like a network looks more and more like Wi-Fi. Ultimately, I think you do want all of the technologies, you want all the spectrum to be productive, and I would find that if you dedicate spectrum just for small cells, you may end up leaving a lot of spectrum on the table versus saying spectrum ought to be productive in all networks, across the board, in all places, towers, small cells. And that typically is what provides the economics to drive the device ecosystem for that spectrum to be used in the very beginning.
And maybe, Ken and Eyad, could you talk a little bit about how you think about prioritizing where you're deploying your small cell solutions? And I'm trying to think if, is there anything Lynn and Robert can do to sort of get up the priority list? Like, how do you think about that? For both of you, I think.
Usually there are multiple drivers. So we have allocations of capital for business customers based on business needs. We have allocation of capital for our customer care centers to support customers' needs for, if they don't have the proper signal or if they don't have the right coverage, or if they just move from one place to another. I think femtos for us more about fast response right now to say your situation has changed, either change phones or you added family members or you move from place to place and you don't have coverage. How do we give you a quick response while the macro network responds? So we allocate capital across the different business requirements and be ready to support them all.
Got it.
I would say, spend a lot of energy trying to figure out where do people want this service, because we don't want to put it in locations that they're not using it. And, basically you try to find locations where people go like this, where they're non-mobile. And, what we found is, as was mentioned earlier today, it's in the home more than anywhere else. There's a lot of small enterprise opportunity there, pizza shops, restaurants, et cetera. But there are some outdoor locations too, parks, tourist attractions. And, I think if you just stop and think for a minute, where do people stop and flip out their smartphone? They will almost all fall into one of those categories. So, once you sort of settle on that, it's a pretty easy analysis to pick locations. You find the residences, you get the right SIC codes out of the databases, and you talk to customers in that market and say, where are the outside places you go. It's a fairly straightforward exercise to target locations for broadband mobile services.
Got it. Great.
Turn to some of these.
No, go ahead.
Let's see if I can, there's a lot of different handwriting. So one question is, what are the biggest catalysts to mass market small cell deployment? So competitive differentiation, we've talked about, I think a lot of the carriers in the early days of femtocells, a lot of it's been about satisfying, sort of as a customer retention tool more than anything else. Is that sort of, the main driver? Operations, real estate, what are the main catalyst, what if you could sort of change one thing in the marketplace that would, multiply the number of small cells by 10, what would it be?
So let me tell you, the problems got solved so far or about to be solved. The consumer-friendly part of it is solved. It is self-configurable, self-manageable. Urbana talked about what they've done. I do think that that's solved. A lot of the core issues are on 911 and safety and CLIA, and all of that's been solved. And VoIP. We're in the process of solving the reuse of spectrum, as you've heard earlier from Jim and the ALU team, with the standards from LTE around release 9 and 10. I think that's largely solved. The two problems left to really go expand widely is about access to building rights and access to backhaul, if you want to go beyond sort of the consumer deployment. And we need to figure out a way that access isn't a 2-year negotiation process and a massive multi-$100,000 to get into a federal building or to get into a private building or to get, we've got to figure out a way to create more shareable infrastructure there, whether that is through sharing the actual equipment itself for the femto or through finding ways to share access and to share rights to get there, but that's the next wave in my view.
Who are you typically negotiating with for those rights? So from the building operator standpoint, I mean, is it the tenant? Is it the bill? I mean, I know that, some, professional firms or enterprises, they'll install their own Wi-Fi or hire someone to install their Wi-Fi. How much coordination has to happen at the building level with the tenant? And, to your point earlier of taking engineers out of the equation and making things more self-configurable, what are the things that can happen to sort of allow maybe the users on the demand side to sort of pull in this infrastructure, reuse the Ethernet they've already got in their offices and their enterprises, that kind of stuff, rather than, pushing it in from the carrier side or even from the building operator side? Anyone have a perspective on that?
You have to speak categorically. Part of it, obviously tenants, particularly larger tenants, can go out, put in their own femto cells, put it over their own provider to get backhaul and provide local floor or multi-floor solutions. So there really isn't an impediment to that. Part of the challenge we face as an operator is, say, not playing favorites. If we have carrier A, carrier B, carrier C, and we don't really have an agnostic environment, we don't want to get in the position of saying, okay, we've installed 1, now 2 and 3 want to come in, and you end up in this kind of race, or you end up with select provisioning. So anything that leads to more common carrier agnostic solutions is going to help break that. Part of it is also, admittedly, there's a little bit of a what's in it for us. Yes, it's good to have it as an amenity there, but coming in asking for access rights to something without a clear business case for why that makes us a better owner, a better operator. And there is some argument to be made that providing it for your tenants is good, but that doesn't necessarily ring at the cash register all the time. So there has to be a lot better tie-in between this service and of what makes it profitable for us, not to overly bottom line it.
So we have two clarifying questions, I think, for the property owners. One is, I think, Lynn, you'd mentioned the public safety requirements. So could you maybe just talk a little bit more about exactly what the public safety requirements are on real estate owners? And then the other one, for both of you, I think, is in terms of going forward, do you see the wireless coverage as part of just the IT infrastructure? So you mentioned a little bit about retrofitting old buildings, but in terms of going forward, is it just part of the standard IT infrastructure? And if not, sort of what will it take to get there?
I'll address the public safety requirements. Particularly, this has been an issue for us in California, and I believe also in Washington State. We're starting to have some issues there, and it primarily gets down to, from our perspective, is unanticipated costs, that have been layered on top of us in order to get our certificate of occupancy that weren't anticipated several years ago when the original, pro formas were done for the building.
And so the requirement is to have coverage over some...
Primarily for fire and police coverage in our buildings. We have a number of buildings that are built over garages, underground garages, where there's a lot of issues in reception. And the challenge is that the standards and the requirements aren't consistent. And so, and they can vary by locality too, which also makes it very difficult to try to come up with a cost-effective solution, and for our developers and our construction teams to really know what they're going to be dealing with 5 years from now when the building actually is opened.
Got it. And how about the other question, the going forward, is this just part of the standard, is this sort of just becoming part of the standard IT
For us it is, but we can do it very inexpensively. It's not great service. It's the guest access type of Wi-Fi that we're talking about, and it's really just in our resident gathering spaces. We've tried ubiquitous Wi-Fi service in a building on a subscription basis, and what we found is that the penetrations were very, very low. Our residents were not willing to pay for it, or the reception wasn't good enough, the speeds weren't fast enough for them to feel like they were really getting value from it. So the carriers that we had used were struggling with really low penetration numbers after putting in some investment.
I see. And on the commercial side, similar?
Yeah, very similar. What we found is in our larger markets, when we went to the big tenants and said, would this be a valuable amenity to particularly the public network, the guest network, they said, we expect to provide that for our clients. So we wouldn't look to you to do it. We provide that as an amenity to our clients who are coming in to visit us, and wouldn't look to you. Now, certainly if there was a better infrastructure to deliver that, that would be a good thing, but they're not looking to us to provide it. But corporately, we're clearly baking it into our own operations.
Okay, so let's do another one. So there's a question, I don't know if it's something you think a lot about privacy. So how do you address the issues of privacy between Wi-Fi, femtocells? Are there any differences that you see when you're deploying networks from that aspect?
Yes, there are. I mean, Wi-Fi has a checkered past in terms of privacy. I think
is that better than a cesspool or worse than a cesspool?
It certainly doesn't top the cesspool comment. I think that one's really the pinnacle. I think the standards bodies have done and continue to do nice work. There's a number of activities underway, Hotspot 2.0, for example, that are working to tighten that up. The mobile operators, there's a number of organizations involved in that, and we do think that's a critical piece to what you might call carrier-grade Wi-Fi. So that's something I think the industry is working on. Again, I think that the technological challenges either have been knocked down or will be in short order. And it's getting back to the device ecosystem and getting that technology into these millions and billions of devices out in the network. But it's something that I think the Wi-Fi industry is very actively working. Will it ever match that of the licensed spectrum? It probably can. You make some trade-offs with the device ecosystem and ease of access, but I think things like Hotspot 2.0 are certainly directionally correct and aggressively pursuing that as a goal.
And Stephen, Tom, do you see that as a criterion for when you're deploying your networks?
I guess on the the Wi-Fi side, we've got, we did have a checkered past, there's no doubt about that. We've got WPA2 AES encryption. I think what you'll see a lot more of is kind of end-to-end encryption. So they're not going to necessarily rely on the trust of the network. They're going to encrypt it from device to the endpoint. So I guess I don't see that as an obstacle.
Yeah, for us, it's been more left with obviously the carriers, and to your point on the devices, we are more kind of the pipe that that make it happen. So that hasn't been a big issue for us.
Clearly, femtos and picos are carrier grade.
So coming back to Tom Wheeler's, one of the points he raised in the opening about jobs, which has been a theme of the TAC. I mean, how big of an opportunity is this in terms of, especially for people who are involved in the business of installing these things? If we can sort of find ways to address some of the inhibitors that we've been hearing about, and kind of, if the market continues to ramp up, is this a meaningful growth industry, I guess, is a way of thinking about it?
Well, I guess if I look at the the coverage requirements on the enterprise side, we've gone from early 90s where 100,000 square foot. 5 years later, it's down to 25. A couple years after that, we're down to 5 and 10, and now we're building out small cell deployments 1,500 square foot. That's not a very big space, and that's what we're down to at this point. So for the high performance wireless, I feel like we're there already.
Yeah, I think from our perspective as well, I think it's both from a deployment perspective, but also from an operational perspective, right? These networks need to be maintained and operated. One thing is the more technical side of it, but just kind of the break and fix and a lot of elements related to that as well. So just talking for ourselves, we use a lot of contractors, a lot of people that are involved in our projects to both make them happen from a deployment perspective, but also very much so from a ongoing operational perspective. So I think from a employment perspective, that should be good news.
If you, again, back to the just simple numbers, if we're going to have 10 small cells for every macro cell out there, you're talking about hundreds of thousands of base stations. And we're in the middle of deploying these things, and I can tell you there's a lot of person hours involved in getting those out there. So I think it's, there's a very straightforward part to that answer, and that is that 100,000 units to hundreds of thousands, you got to get deployed, turned up, tested. There's a lot of work to be done there.
Yeah, I mean, I think the pent-up demand for in-building is very high. There's no question about it. It'll continue to grow. I think if you found a way to take a little more risk out of it, that it can be truly a shared infrastructure, then you end up with an incentive for capital to come into it. It doesn't matter how many billions we spend, Sprint or Verizon or AT&T, there's only so much we can spend, even if the consumers and businesses and others are looking to do more. If there's a way to remove risk by removing the dependence on any specific entity, that this truly is a shared infrastructure, I think you'll see different risk capital models that would evolve to invest in this business.
Well, that might be a good place to end the panel, give people time for a little bit of a break before the next panel. I think I heard, I think that's well said, yeah, and I think that's a central question for the next panel, which will deal with policy and other solutions. Some of the themes, just to recap real quickly, that I wrote down were, so ease of entry to the market, how do you de-risk it and how do you sort of accelerate it? Ease of entry to the market, self-configuring networks, carrier agnostic is one theme that came up, leveraging existing infrastructure, the cable plant, other assets that are out there, maybe cleaning up or adding more spectrum and Wi-Fi, consistency of the codes and regulations that you have to deal with on the property side, all with an eye towards de-risking and bringing more capital. Hopefully we'll address some of those themes in the next panel. Thank you very much.
Yes, thank you.
Well,
Good afternoon, everybody. I'm Julie Knapp, the Chief of the Office of Engineering and Technology. I'm privileged to be joined by Amy Levine, who is the Wireless Advisor to Chairman Janikowski. We've had a couple of great panels, great lunch and speech, and so we've got a tough act to follow. As Tom said at the start of the day, the idea for this forum grew out of discussions that we had in the Technological Advisory Council. And one of the objectives of this, other than listening to the great discussion and the ideas that we've changed, is to come away from this with some thoughts about what can we do going forward to either remove obstacles or to accelerate deployment of small cells, much of which potentially could be done on the private sector side. And as Tom highlighted, the regulatory process is not always perhaps as quick sometimes as things that can be done on the private sector side, not ruling out the potential if there are rules that maybe need to be relaxed or modified in some way, or new frequency bands. Those are all things I think we would want to think about as well. But the real challenge for this panel is to try to take what we've heard and come up with at least a direction for policy initiatives that we may be able to start with. And with that, just some words from Amy as well.
Yeah, just briefly, thanks to everyone for being here today, and thanks to all of our panelists for doing the panel and for the time that you spend with the TAC. It's very much appreciated. As many of you know, Chairman Janikowski has said that one of his primary goals is seeking ways to get new spectrum, free up new spectrum for wireless services, including getting authority from Congress to conduct voluntary incentive auctions. But as important as looking for more spectrum is advancing the efficiency of the spectrum that's already out there and finding ways to more efficiently use spectrum. It gets harder and harder to find new spectrum, to repurpose spectrum for other purposes, and that's why technologies like dynamic spectrum sharing become very important, but also spectrum efficiency. And so continuing to find ways to use spectrum more efficiently is ever important.
So with that, let me just quickly introduce our panel. We have, just going down the line, Brian Daly, who is the Director of Core and Government Regulatory and Standards Area at AT&T. Next in line, we have Paul Mankiewicz. Paul is the Chief Architect of Mobility Solutions at Juniper Networks. And then Jesse, yes?
Nothing.
Did I blow your last name?
No, he's a friend of mine.
I'm sorry. And then Jesse Russell, who's the Chairman and CEO of Inc. Networks. And then Dennis Roberson, who's Vice Provost at Illinois Institute of Technology. And finally, Russ, and make sure I'm pronouncing your name correctly, Garrick?
It's like a J.
Like a J, Jarek.
We'll stick with that.
Okay. Who's with the office of the...
Too close to another word.
Who's with the office of the Chief Technology Officer at Cisco. Brian, we'll start with you. We're going to follow the same format that we have for the rest of the day. Your kickoff question is, would universal off-the-shelf femtocells be a workable solution, and what would it take for carriers to support them on their networks? And for each of these first questions is 3 minutes allowed for the answer.
I'll watch for the clock then. Thank you. Well, first let me say that AT&T as a whole are very interested in research, development, and deployment of small cell technology of various flavors, whether it be femtocells, metro cells, DAS technology. And we provide leadership in some of the organizations like the Femto Forum, looking at both the evolution, the existing and evolution of femto technologies to future capabilities, including enterprise. As far as the question itself, from a carrier perspective, I think first off we need to address some of the technological challenges that would exist with universal femto deployments. When we look at femtocells, one of the important considerations is that they be optimized to work on the networks and also minimize interference that they could potentially provide to the macro networks. Given that, femto deployments, whether it be universal or non-universal, have to be under the control of and consent by the licensee of the spectrum which they're operating in. Because if they're not, they could potentially cause interference, which ultimately will degrade the entire system, and it's really important that that be addressed. It's also important to understand the interface between the femto system and the carrier network itself. And the backhaul we've heard about being discussed in many of the panels this morning so far is going to be one of the key challenges. When you have a universal femto system supporting multiple carriers, how to get that backhaul to each of the carrier networks is going to be one of the areas that need to be explored and researched and addressed before these systems can be deployed. Today we look at broadband network backhaul on residential femtos, either through cable or DSL networks. There's also microwave technologies that are proposed for small cell. I think we need to look at how those can be integrated into a universal femto supporting backhaul to multiple carrier networks as well. The other issues to be concerned with are when you're looking at universal femto technology, there are many technologies and many bands employed today in carrier networks. Everything from the 700 megahertz, 800 megahertz, 1900 megahertz bands, plus many of the devices also support international bands for roaming. So what bands are these universal femtos going to work in, and how are they going to support multi-carrier environments is going to be a real consideration. And also with that are the technologies that are supported. You've got CDMA 2000, 3G, UMTS, HSPA, LTE on the horizon and deployed and on the horizon. So which technologies need to be supported within these universal femto cells, and those considerations need to be accounted for as well.
Okay, great, thanks. Go ahead.
Nicely timed. Russ, I'm going to turn to you next and ask, how should we think about the relationship between licensed and unlicensed small cell solutions? Should we be looking at both? Are they complements to each other? Do they compete with each other?
No, I think, me, right?
No, I'm sorry.
Russ. Okay.
The other Russ.
So I have a quick slide. If we could put up my slide, just sort of summarizes some of the points today in terms of the drivers for change here. And over the next 5 years, the forecasts are for a 21x growth in the mobile data across the network. Also a lack of spectrum, and I'll call it a challenge to rapidly increase cell sites. Those point to the issues that providers are going to have with congestion as well as users on the network. The other one is a shift from outdoor consumption to indoor, which we've talked about earlier. And Wi-Fi already supports about 30% offload today, and mostly on the residential side. And then there's the economics of indoor offload and small cell sites. It's becoming much more economical from some of the cost advantages with the femto and picocells. So with that in mind, in terms of whether they're rivals or complementary, I would say they're much more complementary in nature from the perspective of looking at it. There are issues for indoor coverage with traditional licensed cell coverage inside buildings. So Wi-Fi has done a great job at fixing some of those in the unlicensed area. So they're very complementary there. So there are coverage-centric problems in that area. I think the bigger challenge is a seamless experience for users between Wi-Fi and wireless, so to speak. So one of the big pushes in the industry has been around this Hotspot 2.0 that was mentioned earlier today, that provides authentication and discovery for devices, whether they have smart cards or not. And that's going to make a big difference, I think, in terms of the user experience as well. I've heard that, in the previous panel, Wi-Fi was called a cesspool, but it's a good cesspool that we're all swimming in.
2.4 was.
Okay. And I think moving forward, the disparity between wireless or unlicensed and licensed will also diminish to some degree. Bottom line, across the industry, I think the real key is that we need to put all available spectrum to work in the best way to provide solutions to end users, and we're going to have to meet the demands of the network.
Thanks, Russ. Jesse, you're up next. That's fine. Would a new license ban for small cell use be a viable solution for in-building coverage, and how would it work?
Well, obviously the answer is yes, but let me explain. Is what they always tell you from a legal point of view. I think what's happening right now, Julie, is that we're at a major tipping point in our industry. And I've been around it a long time, and what we're starting to see is the demand for bandwidth is gravely outstripping our availability of spectrum and bands for this specific application. And one of the central places that this is starting to happen is in our high teledensity areas. These are not just inside of buildings, which we tend to think of as picocellular networks, or inside of homes, which are femtocellular networks, or outside, which are nanocellular networks. It's a combination of all of these. And what's really needed now is a new role of spectrum, similar to what we did back in the 80s when we brought about digital cellular. We started to allocate a new spectral band for doing that. What I have seen in my career in this space is that once the FCC takes an action to drive spectrum availability for a specific application, we create industries as a result of that, whether they expand the existing industry or create a whole new industry. I think where we are today is that there is a need for an expanding new industry. Some people refer to it as wireless CLECs, but these will be companies that will start to build these new emerging small cell networks, whether they're building them inside of enterprises, whether they're building them in high density outdoor areas, or whether they're designing these networks that can be deployed and sold inside of residential properties. I mean, that's where I think it's going. And the way I tend to think of this is that we are near the end of an era, what we call outside-in capacity delivery, where we build large cell networks that are designed to deliver capacity to high teledensity areas. I think we're at the beginning of something that I tend to refer to as inside-out networks, or inside-out networks, where we're now starting to build from the core of the enterprises. These are very, very high bandwidth networks. And as you start to look at the expansion of tablets, the expansion of high capacity devices, whether they be machine-to-machine type devices that are emerging inside of these enterprises, or whether they are man-to-machine, all of these are creating new bandwidth demands that need to be addressed. And the only way I think you can address that is to allocate spectrum targeted at doing that. I don't think any of it will become stranded, because it's going to be used outside, inside, but it will be used where the demand for high teledensity is prevalent, and that I think it's going to grow and drive the cellular industry. So I just think you should look at it as a whole new dimension of the cellular industry, and there will be a lot of players in it. It will be the national carriers, it will be new entrants, and it will be a role for real estate owners as well to play in that process, right?
Great.
Thank you. Dennis, what are the research challenges that relate to the production and deployment of small cell solutions?
The research options are numerous, even though we're actually very, very far along in the process at this point. Following my good friend Jesse here, I have to share a thought that Marty Cooper, the father of the handset, if you will, he always points out, there is no cellular shortfall, or no shortfall of spectrum to meet cellular or other needs. It's just that we haven't made the cells small enough yet. and that's sort of a lead-in to the topic of the research that we need to do. And there are a lot of, I don't fully subscribe to Marty's point of view, by the way, but it does illustrate a key element of what we need to do. It's a balance of allocating more spectrum and much, much more efficiently using it, be it inside out or what have you. The research challenges are numerous, and I broke them down into sort of the bottom level of the stack, the RF-related challenges themselves, and there are several in that domain. Systems challenges, challenges with spectrum itself and the allocation of it, the human experience that we have, and then the economists part of the research challenge. In the RF domain, we need to be focused on the semiconductor side. How do we make the devices at the bottom level that can handle all of these bands that have been talked about, so that we're not struggling with a chip that just handles the needs of one carrier or one set of spectrum, but rather can cover the full range. Associated with that are filters and amplifiers and the like that have to be able to accommodate those needs, and antennas that can cover the full range. From a system standpoint, there are challenges with integration with existing networks, and the carriers, like Brian, are very concerned about that. Multi-technologies as we look at the generations, and the integrations that hasn't been touched on nearly enough with sensors and control networks, especially when we talk about buildings. There are the challenges of functional distribution. Do we have the right alignment, or do we need to move things? The challenges of the dynamism of the environment, reconfigurable networks that are going to be required, and especially are required in large venues where you have peaks of demand that come and go rapidly. Backhaul, the huge need and drive that is there is going to cause us to do a great deal of more work in looking at backhaul. And then the migration itself, the continuous migration of the technology, including heterogeneous networks. From a spectrum standpoint, usage and sharing are key, the allocation, the proper allocation. Human experience, though it's come a long way with the boxes, there's still more work to make it fully easy to use. And finally, the economists, the business models, the capital models, the end-user device models that have to be in place to handle this, and the global rationalization. So there's a great deal that has to be done across that whole range in the research point.
Thanks, Dennis. Paul? And it was a nice segue, bringing up the backhaul as well. How do the core networks need to evolve to accommodate millions of small cells?
Okay, well, thanks, Julie. And I was teasing you that I've been around so long, my title never matches what's on my thing.
Oh, that's right. I thought I pronounced your name right.
Well, we've been doing, but we've been doing this for years. Every time I switch. So anyway, so let me get to your question. Thank you, everyone, for having me here. I think I have some pretty good news. I've got the easy question, I think. Part of it will be difficult, but we'll start with the top of the question. If I take the network and divide it into sort of two gross layers, the subscriber management and subscriber control and subscriber experience component, and then the transport part, which I would call backhaul. At the higher layer, we've been working for years as an industry, and I mean this across many, many companies here and out there that aren't represented today, to basically deal with keeping and coming up with ways to make the user experience seamless between small cells and Wi-Fi networks and the macro network. And so as far as, the earlier discussion, I think it was in the morning discussion, setting up VPNs and tunnels and security, we actually have a really good handle around that. And so it really isn't that hard to put, and the reason I bring that up is if you think about the small cell infrastructure, it's likely to be shared amongst a number of whatever you want to call service providers, carriers, whatever. Because it's not likely you're going to start, slamming little cells up on top of each other and labeling them AT&T or Sprint or Comcast or whatever. So it is important that we figured out, or had done or doing a good job, I believe, in figuring out how to basically, take a user and point them to the right service provider, point them to the internet when they want to be pointed there, and also do things that are very critical to our country, which are, be able to do lawful intercept and things like that, which I think are also quite well worked out. So from a core point of view, where I'm dealing with the subscriber and their experience, we're well on the way to be able to do that. Where it gets a little more messy with the subscriber experience, and Jim Seymour this morning and others have mentioned the area around, how do I really optimize? So not only can I move the person's session, but how do I really optimize so it truly looks seamless from the point of view, maybe it isn't so hard to have a web download be seamless because I have buffers, but a voice call and things like that, they're more real time, or a gaming experience. And that's when we're going to get into much more complex discussions around how do I optimize which network I'm on, at what time, what data, at what time of day it's moving, et cetera. There's a whole effort, a big effort, which I've spoken about here before, around the area of network optimization and mobility, which is also moving rapidly. The one thing I'd like to say, though, with the transport layer, the backhaul issue, things like non-line of sight, microwave backhaul, very important to this evolving industry where small cells are placed all over the place. And maybe the one thing that tends to get left out is that site access, things that we've worked on the TAC around RF emissions, site access, as soon as we increase the number of these little cells by a factor of 10, they're going to get a lot more noticeable. And you will have issues around those common issues we run into with big base stations today will start to become more prevalent with the small cells. And we've seen that. There was a case on Long Island just last year, where people started popping up, small cells in the middle of the night, and the entire town got all upset. And so, you do need to realize that once they become much more ubiquitous, you will need to be able to streamline the way that we can deploy them.
So let me
just let me intercede for 1 second. Just a reminder that to the audience, we have 2 staff in the back with note cards and pens for questions. So if you have questions, please pass them along. And I think we're also taking them over the web as well. So go ahead.
Great. So you identified a lot of great issues associated with femtocells, this issue of mini bands, backhaul, this concept of wireless CLECs kind of driving this process, the need for a seamless user experience. What are some policy initiatives, whether formal regulations or just things that the Commission or other agencies or other parts of government could do just to encourage deployment of these technologies? What are the things we should be thinking about in the policy space to address these issues? And I'll pose that to the panel.
I think it was touched on in several of the different panels. First off is we need to be able to facilitate deployment. We need to educate local authorities on some of their local codes in order to make sure they don't block or stall deployments. We need to make sure that access is treated non-discriminatory. Also, the venues and third parties themselves need to be part of the solution. We want to make sure that customers can use the devices within those venues that they use every day, and it's not specialized to the point that they have to use special devices or equipment in order to gain that access. And also, we want to make sure that there aren't exorbitant rates charged so that the service is available to customers.
Yeah, I just follow up on what I said at the end, and just to elaborate a little more, I'm totally with Brian in that, there will be a need. We should get ahead of the issue of getting the public aware that these things are coming, the way that we get them permitted. We should get, there's all things from right-of-way access, pole access, what is a service provider versus what isn't. Those all written into a lot of the telecommunication law that keeps coming up. And those are all, just like they were big issues in many different areas of telecommunications, there'll be the similar issues here as we're deploying these small cell networks. And and so don't forget that those, that's what I worry about almost more than anything, is that you won't have that in place, and then we'll get slowed down, as Brian said.
I guess my feedback would be that I think we need to move beyond what happened in the 80s and maybe the early 90s, where we started to think about licensed applications and unlicensed applications. I think we're moving into a new era where we're building all IP networks. We can segregate those networks all the way from the end device all the way through the network and partition it in any way you want. And so I tend to think that the rules and the regulatory process of how quickly we can move forward to allocate bands needs to be addressed, because this sort of tsunami is coming in terms of this enormous amount of demand for bandwidth. And I think we're going to stymie growth. I think the ability to build these types of networks and the kinds of jobs that could be created by building these types of networks are enormous. But if we wait around and follow the same sort of slow regulatory process to get these bands allocated, or as Paul said, communicate to the industry that this is the plan and this is what we're planning to do, that needs to be front and center, such that those that are out there playing, whether it's our company or other companies, the standards bodies are there, right? We've defined a standard which is called 4G LTE. If you look at release 10, 11, or even release 9, we have more than what we need from a technology point of view to support those. We have the standard. What we don't have is a partnership from a regulatory point of view to say, I recognize the need for this new growth engine. I see the value that it will create from a jobs perspective, and as a result, we're going to allocate this much spectrum to launch this. Similar to what happened with the 87390 docket, I think, in 1988, when we were pushing for digital cellular implementation. And that when the FCC took the action, put that out there, companies that were doing R&D, which I was a part of, and many others, right, started to work on the technology platforms, and we started to deploy. But it can't be, well, the industry should lead. Well, lead based on what? Right? If you tell me it's lead based on, here's the spectrum, we'd like to see you guys roll out small cells to deal with high teledensity space, whether it's in buildings, outside, or homes. Here's the spectrum, and forget about this licensed and unlicensed stuff. I think that that's just outlived its usefulness. And maybe this new rules or some hybrid between licensed and unlicensed. What it is, I'm not a regulatory person, so I don't really know, but I think that's the challenge that we face as an industry, and hopefully the government can help, right? I'm sorry, go ahead.
Dennis?
I'm going to do the positive side of this. First of all, one of the things you can do is have a forum like this forum. Which is a very positive thing, I believe, that the FCC has undertaken, and the attendance today and the attendance on the net definitely displays the interest and the resonance with this kind of action. And I think it really does put the topic on the table in a way that we can all learn from one another, because we have such a diverse set of constituencies who are here, and so that's a kudos to you all. I would like to point out, many things that I agree with have already been said, but there are a diverse set of technologies involved, and I think it's important to sort of enumerate those and to think about those as well. We do have femtocells that are out there. At least for me, they have moved forward. Even though they've moved forward rapidly, they've moved forward much less rapidly than I might have hoped. We have universal femtocell notion that would cover all of the carriers in a single device. We have the femtocell-like device that would have unique spectrum that would add a new band into your phone and perhaps a new protocol as well, but that would allow you to dump into that device. That would be yet a different device. There is Wi-Fi itself that does exist, and there's DAS as well. So there are quite a number of technologies that we're talking about, and it's my view that there's actually a bit of a different point of view, a little bit in line with what Jesse said, on how you treat each of those and the support that is provided behind them, and that will propel one or more of these technologies forward by the actions that are taken within the FCC, by the allocation of spectrum, by the rules that are there. And I do subscribe to this hybrid that's been mentioned several times, a step down from full license, but a step up from the cesspool world that was referenced earlier.
We just called them junk bands.
Good.
Russ?
Yeah, so being last, I can agree with what everybody said, and I'd like to add to that a little bit, because I do agree with Paul and Brian that part of the things that are really important is removing any of the barriers to deploying, especially as we move to 10 to the 5th or 10 to the 6th small cells. That's going to become a big issue in terms of where right-of-way issues, things like that. And then there's going to be the powering requirements as well as backhaul and so forth. On top of that, I think in terms of policy, you could encourage spectrum efficiency so that everybody makes the most use of what they have or what's out there, both whether it's licensed or unlicensed. And finally, I think I just want to point out there are market incentives in place for the providers, for vendors, for everybody already. And I think it's a matter of, letting some of that catch up. The demand is there, the growth is there, and the build-outs will occur.
I'm going to do a dangerous thing and completely go off script. But we've been talking about different ideas through the day, and I mean, I think of each of these technology solutions differently, each of them having their merits and their challenges. So let me just take the easiest one, first of all, at least what I think of as the easiest one. So in terms of Wi-Fi, for example, some of the things we heard were maybe some additional spectrum at 5 gigahertz was one of the things I think I heard, and I know that the standards community is doing work on channel bonding to especially large channels and so forth in that area. And I think what I heard, although I think this is also seems to be happening on its own, and I'd like to hear your feedback, is, and without preference for one technology over another, Wi-Fi seems to be working its way into more and more devices, and so it sounds like the standards work has been done, that we can have the self-authentication and immediate access, so the handoffs happen pretty quickly. Is that a fair assessment of where things are on the Wi-Fi front? I'm going to come back to the others in a minute.
No, I think that's a fair assessment on the Wi-Fi front. I think the question is that the solution to the challenge that we face, right? I think if you recall the presentation at lunch, I think it was properly characterized that when you start looking at wireless access to different types of devices, you have these what I would call these priority access sort of applications that require sort of unique capabilities and so forth. Then you have the general community where I want to get onto an open internet and I need to have an open environment to do that. I think Wi-Fi addresses that issue. I think the question you want to ask is the ones that follow beyond that. If you look at that sort of 3 network tier that he talked about, what about the enterprise? Does it really address that? What about the mission critical applications? If I'm a building owner, not that I've never been a building owner, but if I'm a building owner and you tell me that you would like for me to manage my in-building energy system based on Wi-Fi, I'd have a lot of concerns about that, right? Or if I'm a hospital and you ask me to manage the critical movement of medical data based on Wi-Fi frequencies based on the way they're licensed, I'd have a lot of problems with that. So I think, as I said earlier, I think the challenge is we've got to start to get away from this licensed and unlicensed perspective and start to talk about what are the requirements for the movement of data for these different applications, and how should the spectrum, the rules, not the spectrum, but the rules be set up to allow these disparate networks to exist in one network. And I think that's the challenge, right?
If we can, we'll probe that a bit more in a minute.
Yeah, go ahead.
And just on the Wi-Fi issue, any other thoughts on that? I mean,
I think I agree with everything you said, Julius. The only small issue would be whether that Wi-Fi handoff happens quickly or effectively, and that's still being worked out, I think.
In the industry, in the standards?
Yeah. Well, not so much, well, there's some work probably to be done in standards, but there is Hotspot 2.0 helps a great deal. But in terms of, and it was brought up in a panel earlier today where, I think it was the second panel, where, I think it was Steve Lilly who mentioned that certain customers, they ask, is this going to help with my voice handoff calls or anything like that? And that, it doesn't in general.
Right. And there's not the business model there for the providers to do that, really. That's, to hand off your voice services doesn't really create a great economic business model.
Yeah, I think that was an important point that you just raised, is because when you have the Wi-Fi, it's the data traffic that's getting offloaded, and a lot of the voice is actually being handled separately. So you may improve the coverage indoors for your data, but you still have the same problem for the voice.
Which is interesting because the data traffic is the bigger eater of bandwidth.
Right.
It's just the voice traffic has more quality issues tied to it.
Yep. Latency.
Yeah. So the only thing I would add is just another caution is that I love Wi-Fi, and I believe that, when we build these heterogeneous networks, it'll be made up of a combination of all of these, and they'll be specifically oriented, as Russ said, to what they do best. I mean, Wi-Fi, we had the cesspool comment earlier. It's not a completely wrong comment. I mean, Wi-Fi evolved as a very simple system and has now, as you said, the channel bonding. It's continuing to evolve to be more secure, reliable, et cetera, but it's not there yet. And so at the same time, I think, so I don't want us to walk away with the idea, oh, Wi-Fi's set, we're all ready to go. I don't believe that's true. It's a great tool, and it does really great things and can offload a lot of data from the other network. But we're probably not there yet to be able to say, okay, it's a replacement for 3G or 4G with the security and the reliability that those have. So it will be a mixture. And Jesse pointed out, too, it depends on what you're targeting and what part of the market you're going after will determine which parts of the network you'll be using, which gets all back to the optimization idea, which is also optimization on services.
Dennis, you had something, and then
Brian. Yeah, I did, and really it reflects on a lot of what's already been said, but our speaker at lunch pointed out the 3 classes of wireless network that were needed. What we normally think of as Wi-Fi class, best effort, which may or may not meet the needs of or expectations that we have with our carriers. The second level, though, was enterprise level, the replacement for the data network that historically, way back when, was wireless and was wired and had certain very high performance characteristics. But he added a third level, which was medical level, life and death level networks. It could be applied to more than medical field. It struck me public safety might fit into that category, other areas. And as you get up to those higher levels, using Wi-Fi as the offload solutions becomes very, very questionable, and even with the rolling specifications that are there.
Brian?
Yeah, I guess from our perspective, looking at solutions that help us optimize our licensed spectrum certainly is somewhat preferential, but we do believe that unlicensed has its place. In fact, there's been a lot of standards work that has been done and is ongoing, integrating Wi-Fi networks in with the 3GPP IMS evolved packet core networks, so that you have a solution that you can offload to the Wi-Fi networks, yet using your same core network for managing the services. So, and there's continued work going on as well, looking at seamless transition of services between the 2 networks. And I think it'll have its place, and I think the one key is that all the technologies we're talking about are going to have its place. It's just a matter of where they actually fit into the overall grand scheme.
Go ahead.
So a number of our panelists have talked about the desire to see some dedicated spectrum for small cell technology, and one of the challenges with that is, where does the spectrum come from? So we have a question actually from the audience about the role of cognitive radio or dynamic spectrum access capabilities to enable small cell deployment, self-deconfliction, and avoiding expensive truck rolls for installing and troubleshooting technology. So Russ, I'm going to start with you because you mentioned the dedicated spectrum issue in your remarks. Is there a place for cognitive radio dynamic spectrum access in this area?
Sure. I think there's quite a few solutions that have been discussed or technologies discussed today, and I think it's really a matter of what fits best in terms, and we need to leverage every one of the technologies. There's quite a bit out there, and not to do so would really, I think, shut some doors.
I don't know whether it's a mass scalable type technology that could be used, but in certain cases, I think it would be a viable solution.
Yeah, let me just pursue that same avenue, because I mean, the idea that we've been exploring here is, well, is there something, we'll have to invent a term. Licensing light is what we've been using in between licensed and unlicensed. Maybe we'll come up with something new. But the idea of a band that, let's hypothesize a minute. Suppose we found this band. We said, well, we know we can't use it for full-powered, high-site systems. It can't do ubiquitous coverage, but we think we could get a lot of mileage out of it if it was dedicated for the kind of applications we're talking about. I'm interested in the reactions of others on the panel. Is that something, one of the downsides I see, one of the successes of Wi-Fi, and we're going to talk a little bit about femtos as well, is that, well, the band at 2.4, it's available all over the world. And so you've got investment, there's a significant amount of bandwidth. So one of the risks if you identify a separate band is you're carving out a brand new technology and will it catch on and so forth. And I mean, we've tried that actually with unlicensed PCS. It wasn't big enough maybe in the beginning. So I'm just curious of the reactions of the idea of trying to find a spot that's similar to what Jesse's been describing, where there's more certainty than just all out unlicensed, but you'd get the benefits of high reuse from small cells, or maybe itsy bitsy cells. I'm not sure if we call them femtos or picos or what. Thoughts on that? Reactions?
Yeah, I think it's highly desirable. I'm suspecting that that's going to be the view of most members of the panel. We'll see, but I think it's very desirable to have that in place. The harmonization across the world is a challenge because you do need to get to that harmonization point ultimately, but I think this need exists everywhere. And we are, with the enormous growth in traffic, and I think we've all been watching it with our smartphone proliferation, it's drowning everything, and we've got to come to a solution, and it's going to have to come worldwide. We've already heard from different ones that people across the world are coming up with their solutions. But if we can get to that point where we have a licensed light that is really focused on broadband data as opposed to microwave ovens and baby monitors and whatever happens to come along, I think that really will give us a great advantage and great capability that is very much needed and going to be needed. We can plot all the curves already.
I guess my input, Julie, would be that we're at, I talked about tipping points earlier, and one of those is that we've moved away from knowing how to provide coverage inside of buildings. We know how to do that, whether we're using distributed antenna systems, Wi-Fi systems, so we're not building a wireless coverage system inside a building. What we have not gotten to is how do we build the capacity demands for wireless inside of buildings. And so when you talk about this idea of a licensed light that has a very targeted application, which is to drive capacity, then I think that there is an enormous need for that. And I would agree exactly with what Dennis was saying, right? I think that you will find a gold rush to that, in my judgment, right, if that was made available, because the demand is all pent up. And I think if it's now dedicated, which means that we know that there's some guarantee that it won't become, using the negative words that we're using today with Wi-Fi, as long as we know that's not going to happen, then I think the investment community will invest in that, because they can see the returns that they would get out of the deployment of those types of networks, just like I said earlier, that we saw in the late 80s when we said, hey, digital is going to provide us 3 to X times more capacity. Then we started building things to make that happen. And I think to imply that we'll never get to the cost points or price points of Wi-Fi, I don't think that's a true statement. I think we will get there if we take the leadership position and say, this is what we're going to do, right? And I think you will find the technology community, I think you'll find the standards bodies, and I think you'll find the national carriers as well embracing the idea.
And the opportunity for jobs.
No, yeah, in the opportunity.
So we just need to find
jobs,
this
right?
Nirvana band.
I like it.
Exactly.
Go ahead, Paul.
So I'm clearly not smart enough to understand the way spectrum is auctioned, and never have been, but from two technical points that I'd like to put out there, maybe three, is that without a doubt, even though we've come up with all these neat interference technologies for putting little cells into the same band as big cells, it's a lot better to have two separate spectrum, okay? It would just, that will give us some gain, and in some areas where we want to do things with the macro cells and the operator has the spectrum, that will give gain, but it will never give as much gain as having the ability to put the small cells in a different spectrum. And in a way, if you think about Wi-Fi, it's in a different spectrum, right? And so the other thing is that the nature of small cells allows the higher frequency bands to be more useful. As you see, the 2.4, the 5, 3 gigahertz, that area. Whereas we wouldn't want to use that kind of spectrum for the macro cells, it's actually much more reasonable and somewhat even beneficial to use it for the small cells. So that's a good point. And then the final thing is I think we're about to get hit with a wave, and you can see that in some of the work going on in some of the standards bodies like ATIS, where video interaction in real time is the worst thing. We keep talking data's over here and voice, and that's not real time, and voice is over here, and that is real time. The worst thing for a technologist like me is if I take the video and make it real time. Now I've got the latency and the high throughput tied together, and it becomes very difficult. And that's coming. And so, and right, and that's the big thing that I do worry about, is that we're talking about we've only scratched the surface of what we're going to need because of that kind of issue.
On the same thread, that's a question from the audience. Wouldn't spectrum dedicated to small cells be unused in most areas where in-building capacity is not needed? Any reactions to that? So, suggestion that...
Well, I think it begs a different question, right? And that is, are we moving into an era of all wireless environments? And dealing with Paul's point, well, it deals both with asynchronous and isochronous communications. Are we moving into that arena where even data is just as valuable as voice, right? And if we're moving into that arena, then I would sort of beg the question, I'm not sure unless you believe that people are not going to demand mobility. We think the growth of the industry says that people will demand mobility. So I tend to think that you'll have a lot less places, as you said, where spectrum will not be used. But I'm sure today, if you take Wi-Fi, there are certain places where there's no Wi-Fi, right? But people still say it's a very valuable thing to do. Right?
There's another answer to this question, too. This all presumes that people are the ones that use the network.
Right.
And increasingly, we're in a world of things talking to other things. And in that case, you don't have to worry about the basis of the question.
I was just going to expand on that. Yeah, definitely from a machine-to-machine perspective or a non-human communication might be one thing. But if you are talking about people using their devices within this spectrum, certainly it comes into play the transition between those networks and the networks that they're used to using on the street. And I think that could play a factor into whether or not that spectrum is used or unused, because if there isn't a tie-in to the operator's network, what's going to be the incentive for using that spectrum in the building when it's not tied into the network they're used to every day?
Could I just make a quick comment on what Brian said? I would just add to what Brian was saying, is that I think we need to move away from the perspective that identities are only given to maybe machines and to people. We're now moving with the emergence of IPv6 in terms of enough addressing space that applications are also things, and that you're going to see a proliferation of applications that end users with devices may want to directly connect to on a flat all-IP network. And so I think the demand here is not our problem. Our problem really is getting the spectrum there to allow us to deal with the bandwidth requirements to address the demand, right?
So, in keeping with this theme of finding more spectrum, we've talked about the potential role of unlicensed, and we have an audience question about whether it would make sense to bring unlicensed spectrum to market through an auction process, or whether it should be set aside through other processes.
That's a tough one.
That is a tough one.
Everybody wants to pass that one down.
This is clearly an academic question.
Yeah. No, I think that the whole premise of unlicensed, as we've talked about it, is that you have this full access. So auctioning unlicensed is almost an oxymoron in many respects.
Yes.
When we get to what we've been talking about here, however, the licensed light, in that context, it may make sense to have that sort of context. I don't think we would do the heavy-duty auctions that we've had here, and I think we've already had the comment that none of us may be bright enough to understand auctions, but we do have that notion of ownership that may be part of the light or proprietorship or whatever it might be that would connect you more to the spectrum and who uses it and who doesn't. So I think that's a valid idea.
How in a licensed light regime would you envision that interference protections are provided, that there's not bleeding over into other people's use of the spectrum?
Yeah, I think part of it is a more homogeneous usage. You're thinking, at least in my thinking about this area of spectrum, it would be a homogeneous spectrum, or at least more so homogeneous. It would be broadband wireless that we're primarily talking about, as opposed to the cesspool spectrum. Since that's become our coin of the realm today, where it's everything. It is microwave ovens and sulfur lamps and baby monitors and who knows what the next thing is, that anything that comes along can be there and you have to avoid it and you don't know what you're going to encounter. This would be a more homogeneous spectrum where the expectations about the spectrum and what you're going to encounter would be much higher, and therefore, as Jesse's talked about, the opportunity for investment would be much cleaner and clearer because you have more longevity in the sight of what's going to be available
As
for
I say,
you.
we'll have more certainty. Can I just raise not a question, obviously you asked the question.
I don't get to answer.
I guess on this whole issue of auctioning of unlicensed, I'm just thinking about it, and I think the thing that's puzzling to me is maybe a higher level question is, what's the objective? If the objective is to drive revenue to fill our coffers, is it better done by making that spectrum available under certain rules that will drive the creation of jobs, and as a result, it's the same as auctioning, but not auctioning, right? As a way to move the process along a lot quicker and to see what the reaction of the industry would be to that, right? Because if you have the investment community and new entrants, national carriers, others lining up and say, we will start to build those networks because we understand certainty now. It's going to be this amount of spectrum in this particular band. We know the technology exists to do that. We know the standards exist to do that. Then all we need to do is to build out these networks and deploy and employ people. If you're telling me that our objective is to get revenue generated, I would say that's a better way to get revenue generated on something like that, as opposed to trying to find a building owner or a group of building owners that would say, hey, I'll put up money and buy spectrum so I can get my own cellular network inside of my building.
I just wanted to take a quick shot at that question, and I'm fully on with Paul that I don't understand how it's auctioned. But I do think
from the audience.
I do think it would be. I think it would be a challenge to auction unlicensed spectrum, and it really is an oxymoron. I think because when you win an auction, you feel ownership. I think another way, just academically speaking, if you were looking at that, would be to look at it as potentially pay per use for spectrum in that type of an option. That might be one option. The question I would have, is that going to slow down deployment or some type of innovation, or even slow down job creation if you did something like that versus not doing it? So that's the real question that we need to think about too, in terms of that, if you implemented a policy like that. If you auction off, as you auction off spectrum, it's kind of like a done deal. And even if you do a pay-per-use, it's like somebody wants to lock that up in some way, so.
It's great comments. This is one of the few sessions where I feel time constrained. It's been a great discussion, but I do want to hit one more topic before we wrap up. We only have a few minutes left, really. And I'll frame it actually in two parts. Brian, you had the question about the universal small cell and so forth. And so one of the questions we had from the audience, what can industry do through standards, et cetera, to converge on a universal small cell? And so that'll be part A. And part B, I mean, we've gone through the day here today, and as Tom mentioned at the start, you know, there are things that perhaps can be done on the industry side. Of the things that you've heard today, anything that struck you on the industry side that perhaps could be undertaken or is going on and could be accelerated, or new initiatives? I'd just be interested in any thoughts you might have on that front. So part A, universal small cell, anything going on there, and then I think more generally the things that can be done on the private sector side to facilitate small cells. Do you want me to start at the other end, Brian? So we'll start with Russ.
Okay, so taking off part A there on the universal small cell, I think it was addressed earlier in one of the panels that it's not, the technology's here. It's a capability. It's a matter of, I think, more or less, what's the business case to do it? And you know, what's the market for it? And can you repeat part B of the question?
Of the things that you heard today.
I'm buying time.
You got a plane to catch. Of the things that you heard today in the discussions, was there anything that struck you, or maybe you didn't hear today, that can be done on the private sector side to accelerate deployment of small cells? I can come back to you.
Let me pass that. I'll handle A. We'll pass it down. I've still got the toothbrush comment in my head that scares me.
FCC. Yeah, Dennis.
I just wanted to pick up, hopefully to address the second part of the question, but to piggyback on something that Russ said earlier. This whole idea of pay for usage, right? Something that I think the industry can do today, right, is that the national carriers have spectrum to get the whole small cell initiative going. There's spectrum that exists today. We don't need, the FCC doesn't need to do anything. I think the question becomes, how do we get the national carriers to move into a space where the buildings that they're not going to build out for whatever economic reason, they're not going to do it. How do we get them to say, but there's still spectrum in these smaller locations that, as the guy from Brandywine was speaking about earlier, well, my building may not be among the top buildings where AT&T may want to do it, but there may be other people that want to do it. Would the national carriers be willing to say, well, okay, for you to put this network in there, I'll give you some certainty. I'm not going to do it. My spectrum is there. It is not being used. And as a result, then you can use it as long as you pay me for using it. I mean, that's something the industry can do, that we don't need the FCC to do anything, right? I mean, that's something that can happen today, right? If the national carriers want to do it.
We only have a few minutes, so.
Yeah, it's effectively cellular white space is what he's just described. So that would be cellular white space, but in this case, the owner would be the owner of the existing spectrum. Brian definitely wants to talk immediately after this.
No, we're not doing that. If you can find cellular white space, let me know, because I'd like to use it. I think that's the biggest challenge. Our biggest challenge is spectrum. I mean, we are utilizing all the spectrum we have and need more.
But you have to appreciate what Jesse's suggesting. This is pico white space. This is the basement of a building. This is and I can find lots of white space if you really want it. You know, I can around Chicago. But in fact, my students go out and find it for me as part of my class.
MSA, guys. Yeah. This is in every MSA. It's not just the large MSAs. It's in every MSA. I think the question becomes, do we believe collectively as an industry, do we believe that the existing national carriers will build a small cell network in every enterprise. Do we believe that? The answer is probably not. But there's nothing wrong with that, right? The question is there another way to do it? And can we create, as an industry, not the FCC, right? But as an industry, can we create collectively, or can the FCC help facilitate us doing that? Such that we can build the smaller ones, because there are small companies that say, hey, if I can have $100 million a year business, I'll go do that, right? Even though it's not $1 billion a year business, right? I'm sure there are opportunities like that that I think we could do if the national carriers were to embrace that kind of thinking, right?
And any final thoughts on things on the private sector side that can be done?
That's a tough one.
Dennis?
Remember, I'm a professor. I can give you thoughts all day long.
As long as you don't give me assignments.
For the rest of the audience, Julie is very sensitive. The TAC's normal role is to create assignments that we pass to Julie. So this is his trying to work. He's trying to work this the opposite direction. But I think following this thread, there are a lot of opportunities that could be done in different forms of structure, different forms of partnership that might exist and might work more efficiently, because the drives are different for different organizations. And that does come as a summation of today. We had the two building owners, and I really appreciate them being here and talking about some of their issues. And I think those exist, and it's not that AT&T doesn't want to serve the customers in those buildings adequately or whatever it might be. They do, but they have not quite been able to get to that yet, and it may not be white space in the sense, but it may be from a capacity standpoint. With people, with the monster that was created with iPhone out there with AT&T, and the data rates that have risen with iPhone being there, followed by the Android and all the smartphone activity, there are huge demands that are very difficult for the carriers to meet. Dividing the pie in the way they've already done with Wi-Fi in a more structured way, with money flows associated with it, could be very beneficial and could be accomplished within the private sector. But it does require creativity in order to do that. Creativity on the part of the carriers, creativity on the part of those that have the need from the building standpoint or venue standpoint. I sit across the street from Sox Park, and up and down demand that exists there, and many, many other venues. That kind of structure could be very valuable.
Paul?
So just I don't want to end on a negative note, but but for every
Thank
in
you
the
for your
TAC
attention.
in the TAC, for every discussion we had where someone was arguing about right-of-way access or pole access or whatever, we also had a service provider commenting that they couldn't get building access, right? So it goes both ways, right? Is that you
as a summation of today. We had the two building owners, and I really appreciate them being here and talking about some of their issues. And I think those exist, and it's not that AT&T doesn't want to serve the customers in those buildings adequately or whatever it might be. They do, but they have not quite been able to get to that yet, and it may not be white space in the sense, but it may be from a capacity standpoint. With people, with the monster that was created with iPhone out there with AT&T and the data rates that have risen with iPhone being there, followed by the Android and all the smartphone activity, there are huge demands that are very difficult for the carriers to meet. Dividing the pie in the way they've already done with Wi-Fi in a more structured way with money flows associated with it could be very beneficial and could be accomplished within the private sector. But it does require creativity in order to do that, creativity on the part of the carriers, creativity on the part of those that have the need from the building standpoint or venue standpoint. I sit across the street from Sox Park and up and down demand that exists there and many, many other venues. That kind of structure could be very valuable.
Paul? So just, I don't want to end on a negative note, but but for every
Thank
in
you
the
for your
TAC
attention.
in the TAC, for every discussion we had where someone was arguing about right-of-way access or pole access or whatever, we also had a service provider commenting that they couldn't get building access, right? So it goes both ways, right? Is that we had people that were saying today that the service providers don't do a good job of covering my buildings, but we know even in the wireline access to buildings, there's a huge tussle over getting good wireline broadband access, getting into buildings in cities and things like that. So there needs to be that discussion we've had in the TAC around significant revamping of access in all dimensions is an important component. So now I've passed it back to you, Julie. It's your job.
Well, look, it's been a great discussion. I think we've gotten, if one of our purposes today was to help advance our thinking on what do we do in this area, we've gotten, I think, some terrific ideas. I learned things today that I didn't. I'm sure all our audience, and if we can just give a round of applause for this terrific panel. And thanks to all of you for attending and the great questions we had from the audience. Have a terrific weekend. Thanks.
We were just starting to get to this.
Yeah.